الرجاء من أصحاب البوسترات العلمية التوجه إلى القاعة. الحضور الكريم، الرجاء منكم التفضل بالجلوس. الرجاء من أصحاب العروض العلمية التوجه إلى القاعة لعرض عروضهم.
تيست 1. تيست 1 1. تيست 1. تيست 1. تيست 1. تيست 1. شوف.
الرجاء من الحضور الكريم التوجه إلى الجلوس. السلام الملكي.
ألو. بسم الله بديع السماوات والأرض الحكيم العليم، والصلاة والسلام على نبينا محمد وعلى آله وصحبه ومن والاه. معالي وزير البيئة والمياه والزراعة المهندس عبد الرحمن بن عبد المحسن الفضلي، أصحاب السعادة ممثلي الدول والوفود الرسمية المشاركة، أصحاب السعادة رؤساء المراكز الإقليمية وممثلي المنظمات. العالم يتغير، العالم يواجه التحديات والتغيرات المرتبطة بالطقس والمناخ، والمملكة العربية السعودية أدركت وتفاعلت وبادرت من أجل تنمية مستدامة تحقق للعالم فرص العيش واستمرارية البقاء. السادة الحضور، نرحب بكم اليوم في المؤتمر الدولي الأول للعواصف الغبارية والرملية بالعاصمة السعودية هنا في الرياض. نسعد بكم ضيوف ومشاركين أعزاء. معالي الوزير، أصحاب السعادة، حضورنا الكريم، سعادة وكيل الوزارة، سعادة الرئيس التنفيذي للمركز الوطني للأرصاد، نرحب بكم. واسمحوا لي في البداية أن نصحبكم من خلال هذا العرض المرئي عن قطاع الأرصاد في المملكة من خلال المركز الوطني للأرصاد ودوره في تقديم خدمات الطقس والمناخ.
ابو ابراهيم امشي يا اخوي، هبت الريح الشماليه، امشي، ما هو بوقته يا اخوي، امشي.
يرتبط مجتمعنا بعلاقة وثيقة بالطقس والمناخ منذ القدم، وهو جزء من موروثه الثقافي وحياته اليومية. حظي قطاع الأرصاد في المملكة العربية السعودية باهتمام كبير في مسيرة التنمية الوطنية، استشعاراً للدور المهم للأرصاد في خطط التنمية المستقبلية المرتبطة بمناشط وجودة الحياة واستقرار المجتمع. ويتضح هذا الاهتمام من خلال القرارات السليمة الكريمة بإنشاء كيان مستقل للأرصاد في المملكة تحت اسم المركز الوطني للأرصاد. ويعمل المركز الوطني للأرصاد كونه الجهة المعنية بتقديم خدمات الأرصاد ومعلومات المناخ في المملكة على تحسين دقة ومدى خدمات التنبؤات الجوية وتعزيز القدرة الوطنية على مواجهة التغير المناخي من خلال توفير تنبؤات مناخية موثوقة متوسطة وطويلة المدى. كما يسهم المركز في توفير منتجات وخدمات أرصادية مخصصة وتجارية لتلبية احتياجات جميع المستفيدين على مدار الساعة. وينفذ المركز الوطني للأرصاد مبادرات وطنية ضمن رؤية المملكة 2030 أسهمت في نقلة نوعية لأعمال الأرصاد التشغيلية ودقة المعلومات، ومنها مبادرة تطوير النماذج العددية لتحسين دقة توقعات الطقس، ومبادرة زيادة التغطية الجغرافية، ومبادرة منظومة معلومات الأرصاد والإنذار المبكر، حيث تجاوزت دقة توقعاتنا 95%. ويشرف المركز أيضاً على عدد من المراكز الإقليمية التي تعكس اهتمام الدولة رعاها الله بقطاع الأرصاد ودوره المحوري في دعم البرامج والخطط والمشاريع التنموية ودعم توجهات المملكة المتعلقة بالمناخ، وهي المركز الإقليمي للتحذير من العواصف الغبارية والرملية، والبرنامج الإقليمي لاستمطار السحب، والمركز الإقليمي للتغير المناخي، والمركز الإقليمي لحفظ المعلومات التاريخية المناخية، والمركز الإقليمي لمراقبة الجفاف والإنذار المبكر، والمركز الإقليمي للاتصالات وبث النشرات الأرصادية. نعمل وفق رؤية واضحة نحو تحقيق التميز والمساهمة في تعزيز سلامة ورخاء وطننا من خلال تقديم خدمات عالية الجودة للطقس والمناخ.
احمد ايش رايك نمشي؟
ليه عسى ما
الارصاد منزلين تنبيه ان في رياح شديده بتجي.
دام الارصاد منبهين مشينا جاي.
والله خلينا نمشي خلاص.
المركز الوطني للأرصاد، نحيطكم بأجوائكم.
والآن نفتتح الجلسة ونستمع إلى كلمة ترحيبية من سعادة الرئيس التنفيذي للمركز الوطني للأرصاد الدكتور أيمن بن سالم غلام.
بسم الله الرحمن الرحيم، والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. معالي وزير البيئة والمياه والزراعة، رئيس مجلس إدارة المركز الوطني للأرصاد راعي هذا المؤتمر، أصحاب السعادة الوكلاء، أصحاب السعادة رؤساء مرافق الأرصاد، السادة والسيدات الحضور، السلام عليكم ورحمة الله وبركاته. اسمحوا لي بداية أن أتقدم بخالص الشكر نيابة عن القائمين على هذا المؤتمر لمعالي وزير البيئة والمياه والزراعة رئيس مجلس إدارة المركز الوطني للأرصاد المهندس عبد الرحمن بن عبد المحسن الفضلي على دعمه ومتابعته المستمرة لكل ما يتعلق بقطاع الأرصاد ومراكزه الإقليمية ومبادراته الوطنية، ورعاية وحضور معاليه لمؤتمرنا هذا هو دليل واضح على إدراكه لأهمية الأرصاد ودوره الحيوي في مناشط الحياة الاجتماعية والاقتصادية والتنموية. وقد تشرفت بقرار معاليه بتكليفي مشرفاً على المراكز الإقليمية ومنها المركز الإقليمي للعواصف الغبارية والرملية المنظم لهذا المؤتمر. معالي الوزير، أصحاب السعادة، الإخوة والأخوات الحضور، لقد انطلقنا في إطار مؤسسي يحقق الأهداف الوطنية الهامة في إنشاء المركز الإقليمي للعواصف الغبارية والرملية والمراكز الإقليمية الأخرى، وقد سعينا للتعريف بدور المراكز الإقليمية من خلال خطط واستراتيجيات مدروسة على الصعيدين الإقليمي والدولي. وقد أثمرت هذه الجهود بترحيب كامل من الدول والمنظمات المعنية واهتماماً واضحاً بالدور الهام وخاصة للمركز الإقليمي للتحذير من العواصف الغبارية والرملية، كما تمت الإشادة به وتبنيه من قبل الدول عبر القرارات الصادرة من المنظمات الدولية واللجان على المستوى الإقليمي والدولي. تأكيداً على أهمية المركز ودوره المستقبلي التي ستصب في خدمة الدول المشاركة فيه وتحقق متطلبات الوطن في مجال البحث في المجالات المتعلقة بمنظومة البيئة. واليوم نسعد برعاية معاليكم وإطلاق هذا المؤتمر الدولي المتخصص الذي نطمح من خلاله لاستكمال المهام المرتبطة بأعمال المركز الإقليمي للعواصف الغبارية والرملية في خدمة دول الإقليم. السادة والسيدات، لقد عمل المركز الوطني للأرصاد كونه الجهة المشرفة على المراكز الإقليمية بكامل طاقته لتحقيق أهداف هذه المراكز بدعم من وزارة البيئة والمياه والزراعة، وعلى رأسها معالي الوزير وكافة المستشارين الذين كانوا سنداً لنا خلال مراحل التأسيس والبناء، وسعادة الوكلاء أيضاً. وما زلنا نسعد بهذا الدعم الذي مكننا من تحقيق ما نشهده من أعمال على أرض الواقع لهذه المراكز التنموية التي ستعكس بإذن الله قدرات وريادة مملكتنا وقيادتها الرشيدة. معالي الوزير، لعلي أستأذن معاليكم الحضور بأن أبوح بجزء عما كان يدور في خلف الكواليس بيني وبين زملائي المنظمين لهذا المؤتمر أثناء الترتيب واختيار اسم المؤتمر. فقد توقفت عند اختيار اسم المؤتمر وتحديداً المؤتمر الأول، إذ أنني أعرف بأن هناك مؤتمرات قليلة عقدت من بعض الدول، وكانت هذه المؤتمرات قليلة جداً وقد عقدت بهذا الشأن. وبعد بحث زملائي عن مخرجات تلك المؤتمرات القليلة وجدنا بأنها كانت لأهداف بعيدة عن التركيز على العواصف الغبارية والرملية وإيجاد الحلول لها، وعليه تمسكنا بهذا الاسم. وما أكد ذلك وهذا الرأي لنا ما أفرزته مخرجات ورشة العمل التدريبية التي سبقت هذا المؤتمر بيومين في رحاب الوزارة، وزارة البيئة والمياه والزراعة، وكذلك الجلسات التي عقدت يوم أمس في هذا المؤتمر كانت جلسات فنية، وأفرزت أن هناك جهود مبعثرة من بعض الدول لدراسة العواصف الغبارية وأيضاً إيجاد الحلول لها. ولكن حقيقة هذه الأبحاث والدراسات فقدت البوصلة التوجيهية لها، وكانت هناك عدة أسئلة: هل هي الجهود هذه لإيقاف أو التخفيف من العواصف الغبارية هل هي مسؤولية دولة أم دول أم جهة أم جهات؟ وبقيت هذه الأبحاث تدور في نفس العجلة لمدة 7 سنوات كما ذكر أحد الباحثين، وأيضاً 12 عام كما ذكر أحد آخر، إلا أنها بقيت لم تجد الكيان الذي يجمع هذه الأبحاث ويرتبها ويضعها في مجالها الصحيح. واليوم ولله الحمد بعد انقضاء الدورة التدريبية واليوم الأول من الجلسات الفنية لهذا المؤتمر، وجد أن القرار التي اتخذته حكومة المملكة العربية السعودية لإنشاء هذا المركز هو القرار السليم، وهو الكيان المفقود التي تسأل عنه هذه الجهات البحثية. ولذلك تمسكت إذن أنا وزملائي بأن يكون اسم المؤتمر هذا فعلا هو المؤتمر الأول للعواصف الغبارية والرملية، بل وهو المؤتمر الأميز على المستوى المنطقة، كوننا والحقيقة نعيش بهذه التجارب من داخل هذا الإقليم. فهناك أيضا أفرزت الجلسات يوم أمس بأن ما تتعرض له الجزيرة العربية من عواصف غبارية ورملية يعتبر تأثير اللي هو يعني تأثير معقد، لأن بعض الدول تأتيها العواصف الغبارية منقولة، ولكن في منطقتنا تأتي العواصف الغبارية منقولة وأيضا تنشأ داخل هذه المنطقة. ولذلك هذا المؤتمر هو الأميز من ضمن المؤتمرات القليلة، وسنتمسك بهذا الاسم المؤتمر الأول للعواصف الغبارية والرملية. أكرر شكري لمعاليكم على المساندة والدعم لكل برامجنا وأعمالنا التشغيلية والبحثية، سائلا الله التوفيق للجميع، والسلام عليكم ورحمة الله وبركاته.
شكرا لك دكتور أيمن. والآن الكلمة لسعادة وكيل شؤون البيئة بوزارة البيئة والمياه والزراعة الدكتور أسامة فقيهة.
بسم الله الرحمن الرحيم، والحمد لله رب العالمين، والصلاة والسلام على أشرف الأنبياء والمرسلين، معالي وزير البيئة والمياه والزراعة رئيس مجلس إدارة المركز الوطني للأرصاد المهندس عبد الرحمن بن عبد المحسن الفضلي، أصحاب السعادة، الضيوف الكرام، ممثلي الوفود الرسمية، السلام عليكم ورحمة الله وبركاته. في البداية أسرني بالترحيب بكم في المملكة العربية السعودية، شاكرا لكم تلبية الدعوة للمشاركة في المؤتمر الدولي الأول للتحذير من العواصف الغبارية والرملية، والذي ينظمه المركز الإقليمي للتحذير من العواصف الغبارية والرملية ضمن التزاماته وتوجهاته الاستراتيجية المعنية بتعزيز التعاون بين الدول والمنظمات في الإقليم للتعامل مع العواصف الغبارية والرملية، وذلك بالتعاون مع المنظمة العالمية للأرصاد WMO. كما أن هذا المؤتمر يأتي إدراكا لحجم التحديات الناجمة عن العواصف الغبارية وآثارها البيئية والاجتماعية والاقتصادية، والتي يزيد من حدتها الظروف السائدة في المنطقة من جفاف وتصحر وندر المواد الطبيعية، إضافة لازدياد الظواهر الجوية المتطرفة. ويهدف هذا المؤتمر إلى دعوة الدول وذوي العلاقة من القيادات والخبراء والمختصين والمعنيين بشأن العواصف الغبارية والرملية. وقد سعت اللجنة المنظمة للمؤتمر إلى أن تكون مواضيع أجندته مرتبطة بشكل مباشر بكل ما يتعلق بهذا الملف على المستويين الإقليمي والدولي، استكمالا لما تم بهذا الشأن من ورش عمل ولقاءات ومؤتمرات سابقة عقدتها المملكة، تحقيق الأهداف المرجوة في تبادل المعرفة ونقل الخبرات المحلية والإقليمية، والتعرف على التقنيات والتجارب الحديثة، وتقييمها في المنطقة لدعم التوجهات الرامية لمواجهة العواصف الغبارية والرملية. صاحب المعالي، أصحاب السعادة، الحضور الكرام، لقد عملت المملكة العربية السعودية جاهدة في السنوات القليلة الماضية ومن خلال رؤيتها الطموحة 2030 على تعزيز الاهتمام بحماية البيئة وقضايا المناخ من منطلق دورها الريادي ومسؤولياتها الإقليمية الدولية، وبادرت بإطلاق المبادرات المحلية الإقليمية الدولية لتعزيز هذا الاهتمام، والمتمثلة في اعتماد الاستراتيجية الوطنية للبيئة وإنشاء المراكز البيئية المتخصصة وصندوق البيئة وتحديث الأنظمة البيئية، وإطلاق مبادرة السعودية الخضراء والمبادرات العالمية تحت مظلة مجموعة 20 ومبادرة الشرق الأوسط الأخضر، والتي انبثق منها عدة مبادرات ومراكز، ومنها إنشاء المركز الإقليمي للتحذير من العواصف الغبارية والرملية، والذي أعلن عنه سمو سيدي ولي العهد حفظه الله في قمة الشرق الأوسط الأولى التي عقدت في العاصمة الرياض في نهاية عام 2021، ليكون مركزاً إقليمياً للمساهمة في تبادل وتطوير المعلومات ودعم الخطط والبرامج على المستويين الإقليمي والدولي، وتحقيقاً لأهداف منظمة الأرصاد العالمية في مواجهة العواصف الغبارية والرملية وتخفيف آثارها اجتماعياً واقتصادياً وبيئياً، كونه أحد المراكز الإقليمية الأربعة المعتمدة من قبل منظمة الأرصاد العالمية على مستوى العالم. وتتكامل أهداف المركز الإقليمي للتحذير من العواصف الغبارية والرملية أيضاً مع المبادرات المحلية الإقليمية التي تسعى لحماية البيئة وضمان استدامتها وتقليل آثار التغير المناخي ورفع نسبة الغطاء النباتي. كما يأتي المركز الإقليمي للتحذير من العواصف الغبارية والرملية ضمن 3 مبادرات إقليمية وكل الإشراف عليها المركز الوطني للأرصاد في المملكة وهي البرنامج الإقليمي لاستمطار السحب والمركز الإقليمي للتغيير المناخي. كما أود التنويه باستضافة المملكة ليوم البيئة العالمي لعام 2024 والذي سينطلق في شهر يونيو بشعار الحد من تدهور الأراضي وآثار الجفاف، وهذا له علاقة وطيدة بموضوع هذا المؤتمر. وأيضا أود التنويه باستضافة المملكة لمؤتمر الأطراف السادس عشر لاتفاقية الأمم المتحدة للتحد من التصحر، وهي إحدى الاتفاقيات الثلاثة الرئيسية المنبثقة عن قمة الأرض التي انعقدت في ريو دي جانيرو عام 92، وهي اتفاقية التغيير المناخي واتفاقية التنوع الحيوي واتفاقية الحد من التصحر، والتي تعنى بالحفاظ على الأراضي والحد من تدهورها وتعزيز الاستعداد لمواجهة الجفاف، وهي مواضيع في غاية الأهمية ولها جوانب اجتماعية وبيئية واقتصادية متعددة. معالي صاحب المعالي الحضور الكرام، إننا نتطلع اليوم ومن خلال أجندة المؤتمر الحافلة بالمواضيع بالغة الأهمية إلى زيادة إدراك وفهم التأثيرات الخصائص المعنية بالغبار والانبعاثات خاصة في المناطق الجافة مثل منطقة الشرق الأوسط وشمال أفريقيا، إضافة إلى مصادر تكون الغبار ومناطق تفاعله والتأثيرات السلبية المرتبطة عليه على البنى التحتية وعلى الجوانب الاجتماعية والبيئية واستراتيجيات وآليات التخفيف من حدته. هذه المواضيع التي تطرح خلال أيام المؤتمر ستجعلنا أكثر انسجاما في التعامل مع التحديات المقبلة مع العواصف الغبارية والرملية، كما أنها ستمكن المركز الإقليمي للتحديد من العواصف الغبارية والرملية من تحقيق التزاماته ومستهدفاته على مستوى المنطقة. الإخوة الحضور، نتطلع بوجودكم اليوم كصناع قرار وكشركاء أساسيين وباحثين ومختصين إلى تحقيق الأهداف المرجوة لهذا المؤتمر ودعم مخرجاته وتوصياته بما يضمن لنا فرص النجاح وتعزيز التكامل فيما بيننا. في الختام أتقدم مرة أخرى بالشكر لمعالي وزير البيئة والمياه والزراعة لرعاية هذا المؤتمر ودعمه لمنظومة البيئة بشكل عام، والشكر امتنان للجنة المنظمة لهذا المؤتمر وللمشاركين على تلبيتهم الدعوة وللخبراء على تقديمهم الأوراق العلمية القيمة التي ستساهم في تعزيز وبناء القاعدة المعرفية. والسلام عليكم ورحمة الله وبركاته.
شكرا لك دكتور أسامة. والآن نستمع إلى كلمة ممثل المنظمة العالمية للأرصاد الجوية التي تلقيها دكتور سارة باسرت. Please welcome on stage.
Welcome, Your Excellency, Mr. Abdul Rahman Al Fadli, Minister of the Environment, Water and Agriculture, distinguished guests, greetings to all. On behalf of WMO, the World Meteorological Organization, it is my honor to address you at the first conference on sun and dust storms in the region. And first, I would like to convey the greetings of the Secretary General of WMO, Professor Celeste Saulo, and her wishes for you to have a successful conference. Second, I would like to thank the government of the Kingdom of Saudi Arabia and the National Center for Meteorology for hosting this international event and providing all the support to make it successful. The most recent IPCC and WMO climate reports show clear increase in temperatures, evaporation, droughts, and melting glaciers. At the global scale, year by year, we have broken records on greenhouse gases of carbon dioxide, methane, or nitrous oxide. And we have started to see a growing amount of weather extremes. which also having an impact on the frequency on sun and dust storms. Additionally, in the past years, we have observed an abnormal decrease in precipitation in the Middle East, as well as an anomalous increase in temperature with record-breaking heat waves. The climate system of the Middle East is further complicated with flash floods as well as sun and dust storms. These extreme events are associated with the widespread losses of lives and damages to properties. This confirms the effects of the global warming and the climate change. WMO plays a crucial role in addressing these climate-related issues at global scale. From WMO perspective, we are promoting 3 major initiatives for the coming years. We have a new way of monitoring greenhouse gases based on ground-based satellite and forecasting tools. Then we have also promoting new high-resolution climate modeling so that we will be able to say more about weather and extreme events, which is also related also to the frequency of sun and dust storms. We also have the recent Early Warning Initiative for All, which is supposed to give a boost in the improvement of early warnings in the region, also worldwide, because in this system, sun and dust storm is one of the hazards identified. For the development of these early warning systems for sun and dust storms, here it's crucial the outcomes of the SDS-WOS research program at WMO, and I'm glad to say that Saudi Arabia is one of the key players in this initiative. WMO is actively collaborating with other United Nations agencies, some of them represented today in the room, and we are providing information and guidance on how to assess and address the risks posed by sun and dust storms, and as well as the action plans to combat them. WMO is part of this UN initiative for combating sun and dust storms and is leading the monitoring and forecasting activities. Our support should enable scientists, partners, national meteorological and hydrological services in the region to be key players in shaping climate agendas at all levels. We stand at the intersection of inequality and the climate change, and our strategy must reflect the urgency of the times. We must all work together. Finally, I would like to thank especially the support of the government of Kingdom of Saudi Arabia, its continuous contribution to the WMO activities, connecting especially with sun and dust storms, and its efforts to create capacity in the region to fight against these hazards. Also, I want to mention that the contribution that you are doing to the SDS-WOS program with hosting the regional center in Jeddah. And with that, just I want to wish you a fruitful discussion and anticipate a positive outcomes for the conference. Shukran, thank you.
Thank you, Dr. Sarah. والآن نستمع لكلمة ممثلي تحالف الأمم المتحدة لمكافحة العواصف الرملية والترابية يلقيها دكتور فراس زيادات، فليتفضل.
شكرا جزيلا. السلام عليكم. Your Excellency, Mr. Abdurrahman Fadli, Your Excellencies, esteemed guests, friends, colleagues, I would like to extend my gratitude to the governments of the Kingdom of Saudi Arabia for organizing this timely and important first international conference on sand and dust storms. About 2 billion tons of dust enter the atmosphere annually, affecting over 150 countries in all continents, and threatening the achievement of 11 out of 17 of the Sustainable Development Goals and associated targets. Climate change, including changes in temperature and precipitation, are leading to drought and degrading vegetation cover, is modifying sand and dust storm hazard levels and increasing associated risks. These hazards especially affect farmers and people who depend directly on natural resources for their livelihoods. International efforts to support countries in promoting sustainable practices and policies to mitigate sand and dust storm sources and manage their impacts are growing. In 2017, the UN General Assembly passed a resolution urging UN agencies to consider launching an interagency process to develop global response on SDS. Subsequently, the United Nations Coalition on Combating Sand and Dust Storms was established in September 2019 during the 14th Conference of Parties to the United Nations Convention on Combating Desertification in New Delhi. Comprising 19 UN agencies and non-UN organizations, the coalition currently chaired by FAO aims to foster global action against SDS. The UN coalition is mandated to promote and coordinate a collaborative UN system response that facilitates the exchange of knowledge, data, and good practices, dialogue and collaboration amongst affected countries and the UN system, and capacity building in countries, raises their awareness and enhances their preparedness and response to sand and dust storm in critical regions. The growing need for global and regional cooperation to manage and mitigate the effects of sand and dust storm has recently led the United Nations General Assembly to proclaim 12th of July as the International Day of Combating Sand and Dust Storms. We need to take our efforts forward in implementing the coalition's strategy and action plan to mobilize political will and resources and to strengthen global, interregional, and regional cooperation. We must work together to enhance the management of sand and dust storms in high-risk areas, which in most cases go beyond national boundaries. This conference is a great opportunity to discuss the key challenges and potential solutions. It is also important to share best practices and solutions along the concrete action required to increase resilience, mitigation, and adaptation to reduce the negative impact of sand and dust storm. The coalition stands ready to support countries combat sand and dust storm and reduce impact on different sectors. As the chair of the coalition since 2000, FAO is committed to continue fostering cooperation with all countries. The coalition will continue to share experience, methodologies, and tools in combating sand and dust storms, including sustainable land, soil, and water management to protect people's lives, health, and livelihoods, and to achieve food security. Only through international collaboration with all partners and countries can we address the transboundary and multi-sectoral issues of sand and dust storms. Resource mobilization is a key to achieve these ambitious goals. We need to move to action on the ground to manage sand and dust storms. Wishing you a successful international conference on sand and dust storms, and thank you for the organizers and for the government of the Kingdom of Saudi Arabia again. Thank you very much.
شكراً لك دكتور فراس. أما الآن يطيب لنا أن نقدم لكم هذا العرض المرئي الذي يسلط الضوء على الدور الفاعل للمركز الإقليمي للتحذير من العواصف الغبارية والرملية. هذا المؤتمر قامت على تنظيمه أياد وطنية تعبت وعملت واجتهدت ليخرج لنا في أبهى صورة. والآن مع كلمة المدير التنفيذي للمركز الإقليمي للتحذير من العواصف الغبارية والرملية الأستاذ جمعان بن سعد القحطاني رئيس اللجنة المنظمة، ليقدم لنا صورة موجزة تلخص جهود المركز وبرامج ومبادراته النوعية. تفضل أستاذ.
بسم الله والصلاة والسلام على رسول الله. معالي وزير البيئة والمياه والزراعة، رئيس مجلس الإدارة المركز الوطني للأرصاد، أصحاب المعالي والسعادة، ضيوفنا الكرام السيدات والسادة، السلام عليكم ورحمة الله تعالى وبركاته. لقد جاء إنشاء المركز الإقليمي للتحذير من العواصف الغبارية والرملية تلبية لتطلعات المملكة العربية السعودية للقيام بدورها الإقليمي لمواجهة مخاطر العواصف الغبارية والرملية والتخفيف من تأثيراتها واتخاذ التدابير اللازمة حيالها على المستوى المحلي والإقليمي والدولي. ويعد المركز الإقليمي للتحذير من العواصف الغبارية والرملية رابع مركز على مستوى العالم يتبع للمنظمة العالمية للأرصاد، ويدعم دول المنطقة في مجال تعزيز رصد وتوقع حدوث العواصف الغبارية والرملية وتحسين دقة تحذيراتها وتقييم أثرها والقيام بالأبحاث المختصة، ومسؤولاً عن التنسيق المحلي والإقليمي والدولي مع المراكز والجهات ذات العلاقة. كما يدعم المركز من خلال التحذيرات والأبحاث والدراسات الموثوقة صانعي القرار والمجتمعات والأفراد للاستعداد بشكل كبير لتجنب الآثار الناجمة على العواصف الغبارية والرملية، بالإضافة إلى حماية الممتلكات والموارد ودعم النمو الاجتماعي والاقتصادي والتنمية المستدامة. ويطمح المركز من خلال شراكاته الدولية إلى تطوير الأجهزة والتقنيات المستخدمة في رصد وتوقع العواصف الغبارية والرملية، كاستخدام الذكاء الاصطناعي في عملية التحذير منها، وتأهيل الكوادر البشرية الإقليمية، وإتاحة البيانات والمعلومات، وتشجيع التعاون البحثي بين مراكز الأبحاث بالمنطقة، وعقد الشراكات مع المنظمة العالمية للأرصاد ومراكزها الإقليمية الأخرى والمنظمات العالمية المختصة، والتي سيكون لها أثراً إيجابياً على برامجنا التنموية والاجتماعية والصحية. وتأكيداً لهذه الأهداف، فإن المركز الإقليمي للتحذير من العواصف الغبارية والرملية عزز شبكة الرصد، وقدم العديد من الأبحاث والأوراق العلمية بمشاركة باحثين من دول الإقليم ومراكز الأبحاث الدولية. ونظم المركز العديد من ورش العمل والندوات، كان آخرها تقديم دورة في بناء القدرات لنمذجة ورصد العواصف الغبارية والرملية للدول العربية، وذلك بالتعاون مع لجنة الأمم المتحدة الاقتصادية والاجتماعية لدول غرب آسيا الإسكوا، بالإضافة إلى المنظمة العالمية للأرصاد. كما إن المركز ومن خلال دراسته العواصف الغبارية والرملية رصد انخفاضاً ملموساً في معدل العواصف الغبارية والرملية في عدد من دول الإقليم، ومنها المملكة العربية السعودية بنسب ملحوظة خلال عام 2023. كما واصلت العواصف انخفاضها في معدلاتها التاريخية في المملكة خلال شهري يناير وفبراير من هذا العام بنسب بلغت 72% و30% على التوالي، ولعل ذلك كان نتيجة مبادرات رؤية المملكة 2030، وكذلك مبادرات وزارة البيئة والمياه والزراعة ومراكزها التابعة التي تهدف إلى زيادة الغطاء النباتي ومنع تدهور الأراضي وزيادة معدلات هطول الأمطار، وكذلك تنظيم الرعي ومنع الاحتطاب. مرة أخرى نرحب بجميع المشاركين في المؤتمر من الجهات الحكومية والدول الشقيقة والصديقة والمنظمات الإقليمية والعالمية، مع تمنياتنا لكم بالاستفادة القصوى من مواضيع وجلسات المؤتمر. واسمحوا لي في ختام كلمتي أن أتقدم بالشكر الجزيل لمعالي وزير البيئة والمياه والزراعة المهندس عبد الرحمن بن عبد المحسن الفضلي على الدعم اللامحدود الذي يلقاه المركز الإقليمي للتحذير من العواصف الغبارية والرملية من قبل معاليه. كما أتقدم بالشكر الجزيل لسعادة الرئيس التنفيذي للمركز الوطني للأرصاد المشرف العام على المركز الإقليمي الدكتور أيمن بن سالم غلام على ما يحظى به المركز من اهتمام ومتابعة من قبل سعادته. وكما لا يفوتني كذلك أن أتقدم بالشكر الجزيل لأعضاء لجنتي المؤتمر العلمية والتنظيمية على جهودهم الدؤوبة للتحضير لهذا المؤتمر. والسلام عليكم ورحمة الله تعالى وبركاته.
شكرا لك أستاذ جمعان. والآن ندعوكم لمشاهدة هذا الفيديو الترويجي لمؤتمر كوب 16.
استضافة المملكة العربية السعودية للدورة السادسة عشر لمؤتمر الأطراف UNCCD كاب 16 الذي سيعقد في مدينة الرياض.
حدث عالمي، حدث تاريخي، حدث مهم.
With the Kingdom of Saudi Arabia as host to the Conference of the Parties, COP16.
For COP16 start way before December.
We established what is called the Regional Sand and Dust Storm Early Warning Center.
What would the earth say if she could speak? Would she prevail harsh words upon us regarding her treatment? Or would she speak softly to encourage our change? It may seem she has no voice, yet we need not hear what she has to say to understand her plea. We need only take the time to look, to truly see the mistreatment the earth has endured because of us. She wants nothing more than to provide, to nourish, and to heal.
السلام عليكم ورحمة الله وبركاته. We'd like to invite, yes, he is, Dr. Ayman Ghulam, please. Professor Baron Joseph, Dr. Jum'a Al-Maskari, Dr. Khalid Abdul Qadir, Mr. Jum'a Al-Gahtar. We are pleased to start the panel discussion with the first International Conference on Sand and Dust Storms, SDS, under the patronage of His Excellency, the Minister of Environment, Water and Agriculture. Let's welcome our panelists and then start our discussion. First of all, we would like to welcome Dr. Ayman Ghulam, CEO of the National Center of Meteorology in Saudi Arabia. Dr. Ayman awarded a PhD and graduated from the University of East Anglia in the UK in 2007. November 2019, he was appointed the CEO of National Center for Meteorology in Saudi Arabia. He is a permanent representative of Saudi Arabia at WMO. He is also a member of the Arab Permanent Committee on Meteorology and Climatology and recently appointed as president of the committee. He is also a member of the Permanent Committee of Meteorology and Climate at the GCC and the High Authority of Capacity Development at INCA. Recently, he was appointed as chairman of the International Committee for Tropical Cyclones in the Arabian Sea and Bay of Bengal. Congratulations, Dr. Ayman, and welcome to our panel discussion. The next panelist is Professor Baron Joseph. Professor Baron is the chief scientist for the United Nations Conventions for to combat desertifications, UNCCD. He's a professor at the University of Arizona in the USA, where he's also served at a NASA Geospatial Extension Specialist. He was a Fulbright scholar named Marie Curie, a fellow at the University of Alicante in Spain. He obtained his PhD in 2000 in Arizona University. Welcome, Professor Joseph. I introduce the next guest panelist, Dr. Jum'a Al-Maskari. He is a Secretary General of GCC as an expert in meteorology. He was Director General of Meteorology and PR of the Sultanate of Oman with WMO. Dr. Jum'a obtained his PhD in meteorology from the University of Leeds. He was elected as the Vice Chair of the Intergovernment Coordination Group for the Indian Ocean Tsunami Warning and Mitigation System. And he's a chair of Sub-Regional Working Group for the Northwest Indian Oceans for the period from 2015 to 2019. Welcome, Dr. Jum'a, to our panel. The next panelist is Dr. Firas Ziyadat. He's a land and water officer at the Food and Agriculture Organization, FAO, with a specific focus on land resource management and planning. His dedication lays in supporting integrated lands and water management, combating land degradations and desertifications. Professor Dr. Firas play a good role in coordinations with the FAO reports. Welcome, Dr. Firas. The next panelist is Dr. Khalid Al-Abd Al-Qadir, CEO of the National Center of Vegetation Cover and Combating Desertifications, NCVC, in Saudi Arabia. Dr. Khalid graduated with a master and doctoral degree from Texas A&M University, the USA. He worked as university professor in the Department of Geosciences at the King Fahd University of Petroleum and Mineral. He was a researcher in the Water and Environmental Resources Division at the Research Institute, King Fahd University, from 1985 until 1998. Welcome, Dr. Qadir. Last but not least, I introduce the acting Vice President of the Executive President of NCM, Mr. Jum'an Gahtani. He is a chairman of the WMO Sand and Dust Storms Warning Advisory and Assessment System. He is also Executive Director of the WMO Sand and Dust Storms Regional Center. He holds a master degree of atmospheric science in 2003 from University of East Anglia in the UK. Also, Mr. Jum'an is a full member of the Global Steering SDS-WS Committee. He has over the 30 years of valuable experience working in government and private industry sector in the field of meteorology and air quality. Welcome, Mr. Jum'an. We can guarantee a fruitful discussions with these great minds in the panel, and we are starting our session with CEO of National Center of Meteorology, Dr. Ayman Ghulam. Dr. Ayman, since the National Center for Meteorology aligned with Saudi 2030 vision and consider an umbrella of 3 regional projects of the Middle East Green Initiative, Could you please shed light on the NCM initiative to support Saudi Arabia 2030 vision, strategic objectives, and tackle sand and dust storms and climate change challenges at the national and regional level? The mic is yours.
Thank you, Dr. Turki, for this good introduction for myself and my colleagues in the panelist. Indeed, going back to your question, the climate change, now it's real. Before there was a debate between two groups. Is there climate change or it is climate variability? What we are seeing now, it is climate change. When we see that in Europe 2 years ago, in the summer 2021, I think, or two, we saw the drought in Europe, while on the other hand, it was very wet in July in Riyadh. This is unusual. We have extreme rainfall in Riyadh in July. Also, we saw flooding in Pakistan and the West Asian region, while we saw at that time dust storm in Switzerland, which is unusual. So this is climate change. Climate change is increasing, the impact of climate change increasing dramatically, and of course it will cause the severe phenomena like flooding, like droughts, like the increasing in frequency and magnitude of dust and sandstorms, and indeed it will lead to drought. And when we talk about drought, then we will have land degradation, and as we saw in the video, the impact is very dangerous, and of course it will affect economy, lifestyle, the people, stabilities, migration of people, and also many effects, even social effects. So Saudi Arabia, indeed, it is part of this world. This climate change scenarios and the future climate change indicators shows that we will experience in the coming future that very heavy thunderstorms and dust storms in some areas and drought in some areas, and even the pattern of rain, it will be changed over Saudi Arabia. But as I said in my opening speech, it is not one country effort. It is multi-countries, and also it should be global efforts. This is why the Saudi Green Initiative came up, and this is nationally. We have commitment to plant 10 million trees, and then Saudi Arabia started to make this initiative is in place, but it is not Saudi Arabia. We have to have a regional cooperation. Then the initiative of Green Middle East came up, and when our Crown, His Highness Royal Prince Mohammed bin Salman, the Crown Prince, announced in the Green Middle East Summit that we will have 4 initiatives, and 3 of them are based in National Center of Meteorology. So those initiatives mainly are the Climate Change Center, Regional Climate Change Center, and also Regional Dust Storm and Early Warning Center, and the Regional Cloud Seeding Program. Those 3 regional centers and programs now are fully functional. The dust storm, or let's start with the Climate Change Center, indeed started to submit and produce the seasonal forecast, sub-seasonal forecast, and the climate state of Saudi Arabia by yearly basis, and the climate change scenario. we found that, as I said, there are some climate changes in the coming future and the changes in the patterns of rainfall, droughts, and even the dust storm events and frequencies. So from those reports, I'm just mentioning or just telling you the story in very brief because I will respect the time, Dr. Turki. Those reports submitted to the other agencies and governmental sectors, but inside and internal the National Center of Meteorology, we expose also those reports to the Regional Center of Dust Storm and Sandstorm Early Warning, and they started to plan their strategic plan according to those scenarios. If we will have drought in some areas, that means we will have some frequencies or the increasing of dust storm and sandstorm frequencies and magnitude. So we have to take our mitigation plan and how to confront this event. And then the regional program of cloud seeding, they also took these reports very seriously and started to build up his plans. So we decided which areas we can start the cloud seeding programs, and this is what happened exactly. And if you are familiar with Saudi Arabia, it's a desert country, but last year in 2022, if you saw the social media, you will see green Saudi Arabia. And this is in the social media. You can just click in X platform and say Rabi' al-Saudiya or Saudi Spring. You will find how the Saudi Arabia is now from desert country to green country. And even yesterday, I showed my colleagues from GCC countries that how is the train going from Jeddah to Mecca is passing through very green land, which is unusual. So this is, Dr. Turki, what are the contribution from the National Center of Meteorology in combating the desertification and also the mitigating the impact of the climate change through those three initiatives, which is under the umbrella of the Green Middle East. Thank you very much.
Thank you, Dr. Ayman, the CEO of NCM. Great informations we heard today. Thank you indeed. We would like to move to Professor Parveen. Just a short questions regarding what the role of UNCCD with regard to sand and dust storms. Can you give us just a short talk about it? Thank you.
Thank you very much, Dr. Turki, and thank you all for the honor of being here. It's been really very interesting and an excellent conference so far. I think a good place to start is to recognize that the UNCCD is the global compact, the global agreement focused on land. And Dr. Ayman, I was very pleased to hear, I was going to say you're thinking of it as a problem from the atmosphere to land, and we think of it as land to the atmosphere, but you actually did both in your excellent remarks. And that's the basis here, right? Land is underneath all of these issues of climate change and biodiversity loss, and if we can ensure that land is more healthy, we can have less problems in those domains and certainly more control over sand and dust storms. But I also want to emphasize we are not like FAO and WMO, who are the doers, the ones that are working with all the countries hands-on with a large fleet of experts around the world. We are simply a small secretariat working with you, with countries that are actually trying to make the policy decisions that facilitate all of this work. So that's the fundamental part of the answer. And it's really been quite a young effort, right? The decisions in the UN context related to sand and dust storms only date back to 2015. General Assembly resolutions, which were embraced by UNCCD, WMO, and UNEP in the production of the global assessment on sand and dust storms, which then led to a policy decision like I was referring to for a policy advocacy framework, which really accelerated the work across these domains. It also helped set the stage for the UN coalition that Dr. Ferris mentioned earlier, and I'm sure he will talk about more, that allows us to work much better together, both as UN entities, but also with countries. It led eventually to a compendium on sand and dust storms, once again, highly collaborative effort. Eventually, finally, now to a guideline for countries on the integration of sand and dust storm management into key policy areas. So I conclude by saying you have the ability to influence the UNCCD by pushing the ambition on that policy agenda, and in turn, those policy decisions can accelerate action. Thank you.
Thank you, Professor Brown, for excellent explanations about UNCCD and the role with the SDS. We move now to Dr. Jum'a Al-Maskari. Same questions. What's the role of GCC with regard to sand and dust storms?
Assalamu alaikum wa rahmatullahi wa barakatuh. It's okay. I'm very pleased, first of all, to be participating in this international conference on sand and dust storm. Cooperation between national meteorological services is strong and constructive. Under the umbrella of the Gulf Cooperation Council, as Dr. have mentioned earlier, a permanent committee was established in 2011. This committee is headed by the directors of the National Med Services, who are also the permanent representative of WMO, of these countries with WMO. I'm very pleased, I'm very glad to see 4 of the directors are actually in this room. And that by itself is a good indication and a strong endorsement for the cooperation. This permanent committee within the Gulf Cooperation Council has developed a strategy to strengthen cooperation between the Gulf countries. Just to name a few of the initiatives that they are working on is compliance with the international standards and best practices to deliver state-of-the-art meteorological services, establish networks like network of observing stations and the network of weather radars, training, capacity building and research, and that's really important, at least for sand and dust storm, and also, very importantly, public awareness and many other initiatives. In the field of reducing effect of sand and dust storm, I think there is more to be done. And this is why the National Met Services are counting and looking forward to the product and services that Jeddah node will be delivering, especially in the sort of product that will be impact-based forecasting.
Dr. Jum'a, thank you very much for talk. We move now to Dr. Firas. Dr. Firas, as a chair of UN with regard to combat SDS, can you please give us brief about the growing impact of sand and dust storm and effects to combat it?
Thank you, Chair. First of all, I would like again to thank the organizers and the government of the Kingdom of Saudi Arabia for this timely and important conference, especially that we will have the COP16 in Saudi Arabia in December. This is a very good preparation. And the coalition and the FAO are ready to support the Kingdom and the other countries in preparation for the COP. The growing impact, because mainly of the climate is changing, is uncertain, there is a lot of expectations of more severe storms, more severe events of rainfall, of wind, etc. And there is more expectation of a drought and changes in the land cover. And that also give expectations that, and we start to see it, the severity, the frequency of sand and dust storms is increasing. The impact on the societies, on land, on food, on health, and you name it, there are a growing impact on all of these sectors. In the source area, there is damage to the land and the soil, and therefore less production of food. In the deposition areas, there is also the impact on the health, on the transportation, and all other sectors, including agriculture and food. And therefore, we expect more severity and more frequency. And how do we act for that? We have to work, we saw in this conference, and we will see more about the prediction, the assessment, the identification of hotspots, the identification of sources of sand and dust storms, and also the assessment of the impact. So we need to go with this growing impact into action. And we need to go on the ground and start making difference in the sources and the depositional area of sand and dust storms. As a UN response to this growing transboundary phenomena, the coalition, the UN Coalition in Combating Sand and Dust Storms, was established in 2019 with now 19 UN and non-UN organizations, and also to respond to that and to raise the visibility and awareness about sand and dust storms, the United Nations General Assembly proclaimed 12th of July of each year as an International Day of Combating Sand and Dust Storms. And that's another occasion to raise awareness and to raise the response of countries and partners to combat sand and dust storms. And we stand ready to support countries and regions to combat this transboundary phenomenon. Thank you.
Thank you, Dr. Firas. We move now to Dr. Khalid Abdul Qadir, CEO of NCVC. Nowadays, the extent of green lands in Saudi Arabia is obvious to everybody. We believe there is a huge benefit of combating sand and dust storms. Please tell us the role of NCVC in this regard.
Thank you, Dr. Turki, and I would like to take this opportunity to thank Dr. Ayman and Engineer Jam'an for organizing this important conference. From its name and its title, the Center for Vegetation Cover Development and Combating Desertification, one of the closest center to the aim and objectives of NCM and to the subject of dust storms. Last year, or maybe a few weeks ago, when the center announced, NCM announced that 2023, one of the lowest year of dust storms in the Kingdom of Saudi Arabia. In fact, that resulted from continuous work in the last 4 or 5 years with a lot of programs that it is planned and funded from the government for a protection of land and plantation efforts in the kingdom. In the kingdom now, in each front, on the governmental front, and the private sector fronts, and also from the NGOs and volunteers, all that together now we reached around 70 million trees already planted in the kingdom, and millions of hectares that already now protected. As a first stage in the organizing grazing in the kingdom, one of the hardest and the most effective the factor that it is really destroying and the vegetation cover in the kingdom, which is grazing. Now we have the first phase to control that and to protect around 8 million hectares in the kingdom. And also we have already designated around 500 national parks in the kingdom with an area around 2 million hectares. All of these programs has resulted in very strong results, as everybody have seen. And also, in addition to that, there is a lot of efforts done by other and sisters governmental organizations, such as the Royal Reserves, which now has accumulated around 14% of protected areas in the kingdom. All of that protection, that means increasing the vegetation cover, and vegetation cover helps and stabilize the soil, keep the moisture in the soil, and also reduce the dust movement by breaking the winds on the soil. In the strategic level, also we have just finished and completed a strategic plan and a roadmap for planting 10 billion trees in the Kingdom of Saudi Arabia. And we are planning to reach 400 million trees by 2030 and protecting around 4 million hectares on the lands. All of these efforts together that will reflect positively on reducing the dust storms, and we see there is a lot of collaboration could be done between the two centers and resulted in the good quality of life for the people and also better health to the society. Thank you.
Thank you, Dr. Khalid. We can see a big efforts regarding to increasing green lands, and we would like to thank you for your efforts regarding just to align with the Vision 2030. We move now to Mr. Jam'an. What factor could account for the observed decline in the frequency of dust storms in Saudi Arabia over the previous year? Please.
Thank you, Turkey. Yes, I think we reported this, that we have a decline in the sand and dust storm in the region. And in fact, the last 3 years, we notice a decline from year to year. I mean, 2023 was around 13% less than the average over the 21 years. For example, Riyadh City last year reported only one dust storm. That was in April 28. This decline of sand and dust storm, of course, we are reporting it as is. We will keep reporting this one, and we hope that the trend line will continue down. We attribute this one to what Dr. Khalid has mentioned, the effort that has been done in the Kingdom of Saudi Arabia as part of the initiatives of the Saudi Vision 2030 and the Ministry of Environment and Water and Agriculture and the Center of National Center for Vegetation Cover and the regulations that has been imposed like to regulate grazing, banned tree cutting, and also the important role of the Royal National Reserves in Saudi Arabia. And it's really helping the land and vegetation cover and the native trees to grow. So it's a combination of factors. In addition to that, we have some measurable rainfall in the previous year, but we had comparison with the same rainfall in the previous years, and we have a paper that will be presented in the third day. And we have some explanation, but the trend is going down, and we wish that it will continue as is now. And we will see. January, actually, 72% less than the average of the last 21 years. February is 30% less. So we will see what will happen in March and April. And thank you very much.
Dr. Turki, if you allow me, or just to have one comment that what is my colleague Jaman is saying that also it is something new for us. This is the first time in July in Riyadh we have zero sand and dust storm event. It is the first time in Qasim we have zero dust and sandstorm. So this is an exceptional year. People who doesn't know those efforts, they are saying, I mean from local people, that maybe the atmospheric systems are weak. And this is not a truth. No. Because if this is a true, that why we have some unusual events like the flooding in Abha and also in Baha, and we have in Qasim very heavy thunderstorms with hails, and also we have snow in the north. So there is climate change, but there are some efforts. Actually, this is from the Saudi Green Initiative and Middle East Initiative, and as a two sisters centers, NCM and National Center of Vegetation Cover, we are doing something, maybe it is hidden from the public, that while we are planning for our cloud seeding flights, we talk with Dr. Khalid that if you would like to seed some seeding in those areas, so while we are raining, the seeds will come up, and we have planning, and those are the cooperation between the two centers.
Thank you, Dr. Ayman, Mr. Jam'an. We would like to move now to Dr. Ayman again. The question is, Saudi Arabia is hosting the next UNCCD COP16 next December here in Riyadh. We want to hear from you what outcome you are looking for from the international gathering, and could you please highlight the proposed Saudi Arabia initiative at the World Leaders Summit in conjunction with COP16, please?
Thank you, Dr. Turki. Again, I'll be also very brief, because indeed the COP16 aims to scale up and coordinate the routes action around by integrating knowledge and practice for drought. Also, the drought resilience, of course, and it will bring together countries, experts, and participants to review progress and also the lessons learned in the drought management, and explore the defined joint way forward towards the more drought resilience in the world. Also, if I can just tackle some points of the COP16, like take practical and policy actions to achieve land degradation neutrality, also raise public awareness about the challenges of land degradation, desertification, and drought, also promote awareness about desertification and drought between countries and stakeholders at the international, regional, and national levels, also promote cooperation in the field of combating desertification and magnitude the effects of the droughts through appropriate sub-regional, regional, and national institutions. Indeed, many outcomes will come, but there are three main sectors or approaches of the outcomes of the summit. like an international initiative of SDS early warning platform to support policymakers. The second one is Riyadh Vision to Land Degradation Neutrality, LDN. And also the third one is Riyadh International Cooperation Initiative to combat drought. COP16 main outcomes will focus on something which is under the negotiation and working on them, and will be decided based on the negotiation through the COP16 itself. Thank you.
Thank you, Dr. Ayman. We move now to Professor Baron. Can you please provide us with examples of specific environmental damage caused by these SDS storms and their implications?
Yes. Thank you very much, Dr. Turki. It's a very good question, and I'll give a quick summary. I think yesterday was much more detailed and very effective, the presentations. The good news is that dust fertilizes and sustains both oceans and forests, and it plays a huge part in the Earth's biogeochemical cycles. Dust can increase precipitation, and dust deposition has played a role in soil formation in many parts of the world at large distances from desert margins. For example, Saharan dust fertilizes the Amazon forest by replacing the phosphorus that is eroded from the basin. But the bad news far outweighs the good news. While dust boosts primary productivity of oceans, it could also be having serious effects on coral reefs and a lot of other effects in the cycles that we were just talking about. Dust has also been associated with exacerbating climatic events such as the storms and droughts and the melting of glaciers, all of which were discussed yesterday. Wind erosion removes the good stuff from the soil, the fine particles, the organic matter, what it is necessary for productivity and quality food, and that leads to soil degradation. The eroded material may damage crops and vegetation due to abrasion as well as burying these young plants, and dust can lead to livestock mortality. So that's just on the environment side that we're talking about. The World Bank estimates that globally welfare losses from dust are approximately $3.6 trillion annually. And that in this region, we're talking about 2.5% of gross domestic product, or $150 billion. It's a huge amount that could be reduced. WHO, as we learned yesterday, estimates that 7 million people die from poor air quality every year, and at least part of that is attributed to dust. There are examples too. You've asked for specifics. In 2021, a major SDS event in Northeast Asia killed 200,000 livestock in Mongolia. Hundreds of flights were canceled in China. Health advisories in the Republic of Korea. If you go back a few years, in Korea, an event cost $4.6 billion to the economy, 1% of GDP due to yellow dust. And these examples can be repeated in many other areas. So it's significant, it's event-based, and I'm glad that we're here trying to address it. Thank you.
Thank you, Professor Baron. We move now to Dr. Jum'a Askari. Last question is going to be, WMO Sand and Dust Storm Regional Center have been established and hosted by INSEM. What the GCC leaders expecting from the center in terms of its contributions, in terms of enhancing the SDS monitoring, forecasting, warning, capacity buildings, and achieving the member state goals in terms of environmental protection and improving the air quality, please?
Thank you for that question. I think everything, all what you have said. GCC Jeddah node, as have been mentioned several times, It's linked to the initiative, to the Saudi Middle East Green Initiatives, which was endorsed and it's fully supported by GCC leaders. Since then, under the umbrella of the Gulf Cooperation Council, several ministerial meetings have discussed the issue of sand and dust storm. Ministers of environment meetings, ministers of health meetings have looked at the issue of sand and dust storm. Many workshops have been conducted in this regard. Recently, the ministers of environment for the GCC region in Oman last year, exactly in September of 2023, mandated SDS Jeddah node through the Ministry of Environment, Water and Agriculture in the Kingdom to do a detailed study on the relationship between sand and dust storm and health, and also look at the difference between natural dust and industrial dust. So having said that, basically what's required from SDS Jeddah node is to lead a joint multi-stakeholder effort to tackle the issue of sand and dust storm in the region. And this can be put in three components: monitoring, warning and research, mitigation projects, and adaptation and prevention measures. These three components have already been touched on yesterday, thanks to the network of expertise available in the room, but also were detailed in a workshop that was conducted under the umbrella of GCC in January 22 in Muscat, where ministries of environment, ministries of health, National Med Services, researchers from universities and research centers were gathered together and came up with a plan that can be actually a starting point for the center to go on. Thank you.
Thank you, Dr. Juma. The next question going to Dr. Firas. What is needed to foster a global action to combat SDS? Please.
Thank you. This is very close question to my heart, because we are working on fostering international and global action. I think the first thing to do is to raise the awareness, and this could be happen through education, media. We need to reach out to decision makers as well as to the public to make sure that everyone is aware about the impact and the solutions for sand and dust storms. Solutions in the source areas to reduce, and solutions in the deposition area to enhance our preparedness and planning for emergencies. We need also to identify specifically the hotspots and to start actions, knowledge sharing on the practices that could be happening. In Samarkand in November, during the CREC meeting, which is a meeting for the preparation for the COP16, we launched a couple of publications where we have 150 practices to reduce the source and the impact of sand and dust storms. In addition to this, we need also to look at the financing, the climate financing and other financing for the sand and dust storm. We need to mobilize resources to our countries to start actions and to start some mitigation and adaptation efforts. And that could be linked or should be linked to the climate, to the biodiversity, and to the land degradation. We need to mobilize the commitments of countries and regions and the global commitments to start looking at this transboundary action. We need the countries to take responsibilities on this, and the regions and the world. Last but not least, the resource mobilization is very important, and we look for COP16 to mobilize the political will and the commitments of countries and regions, as well as to mobilize resources to start actions on the ground. Thank you.
Thank you, Dr. Faras. Move now to Dr. Khalid. How do you see potential collaboration between NCFEC and NCM by regional center for dust and sandstorms and mitigation dust and sandstorms, please?
Thank you, Doctor. For example, when we just, as I mentioned, we just finished from the strategy for the plantation of 10 billion trees in the kingdom as part of the SGI. We utilize the suitability modeling, and which includes soil data, moisture, also type of soil, organic matter contents, and all of these. On top of those, we use the climatic data. So the climatic data is very important for suitability modeling, where we determine the location and given priorities to the places where we can plant, where we can start, and type of trees and species that be used. Also, we utilize this climatic data for determining the green belts and also areas where we can focus for plantation and highways, which is very important for safety and also reducing the maintenance cost on railways and also roads. All of that, it is very important to collaborate with NCM for their data. And also, when we are focusing on the R&D, research and development, we require a lot of data and climatic data, especially long-term data collected in the kingdom. Thanks.
Thank you, Dr. Khalid, for a great contribution. Mr. Jum'an, could you please shed light on the achievement of the WMO Sand and Dust Storms Regional Center and the WMO WS nodes for GCC, and what is your next step after organizing this excellent international conference?
Thank you very much. So let me start with the node. First of all, I would like to thank the GCC leaders and the Met Office directors for their support, and I would like also to thank the member of the regional steering group and the WMO and KAUST and also the GCC Secretariat for their dedicated work and effort that has been done in the previous 2 years. Actually, we have lots of things to do in the region. And we are focusing now in conducting, as Dr. Jum'a mentioned, assessment of the dust in our region, starting with the analysis of the dust composition and what type of dust do we have, how much anthropogenic and how much natural, and also factors or the impact of dust on health. As for the center, we are supporting the node with operational forecast for the dust. Also, we have developed 3 numerical models that they are running at different resolutions. And we developed 30 years database that can be used by the researchers in the region. Our scientist has published several scientific papers in dust storms in our region and globally. And we have installed sun photometers and LiDARs in 2 locations in Saudi Arabia, and we are in the process of installing the 3rd one. Actually, we have lots of objectives in the center that we want to achieve. My focus now is to really help or enhance the regional cooperation between the researchers. We succeeded now to engage the GCC researchers, but we are inviting also the Arab and the neighboring countries to be part of us and to work with our scientists in resolving this challenging problem. And I would like to thank WMO for their support and also the regional centers of WMO to our center, and I thank everybody attending this conference. So thank you very much.
Thank you, Mr. Juman. We are ending the panel discussion on sand and dust storms. We would like to thank all panelists for all contributions. Also would like to thank attendees. Ladies and gentlemen, we'll see you inshallah bidhnillah. Assalamu alaikum wa rahmatullahi wa barakatuh.
والآن في ختام الجلسة ندعو سعادة الرئيس التنفيذي للمركز الوطني للأرصاد لتقديم الدروع التذكارية للمشاركين في هذه الجلسة. تفضل دكتور أيمن غلام. أول درع يقدم لدكتور تركي حبيب الله. Dr. Baron Joseph. ودكتور جمعة المسكري. ودكتور فراس زيادات. دكتور خالد العبد القادر. وأخيراً أستاذ جمعان القحطاني. شكرا لكم، ونعلن الآن اختتام الجلسة الافتتاحية على أن يتم بعد الاستراحة بعد نصف ساعة بدء جلسات المؤتمر. وندعو الجميع أيضا لزيارة المعرض العلمي المصاحب للمؤتمر في هذه الغرفة. في أمان الله وشكرا لكم، والسلام عليكم ورحمة الله وبركاته. Thank you.
pointer. I think no.
I think there is, but
You can.
Hello. We would like to draw your attention that we will start momentarily, so please make your way to the main auditorium. سنبدأ بعد قليل. الرجاء التوجه إلى القاعة وشكرا.
السلام عليكم. We can start.
Assalamu alaikum. Please make your way to the main auditorium. We are going to start shortly. رجاء التوجه إلى القاعة الرئيسة. سنبدأ خلال دقائق. الجميع رجاء منهم التوجه إلى القاعة لبدء الجلسة الأخيرة لهذا اليوم. Should I call them maybe? Dr. Sivan, please to the stage. Dr. Omar Hussein, Al-Imam to the stage. Dr. Ala Mhawish to the stage, please. And Dr. Bitrand Fonich to the stage, please. We're going to start the session. There is two. We shall start. They will come. السلام عليكم ورحمة الله وبركاته ومرحبا بكم في الجلسة الأخيرة لهذا اليوم والتي ستكون بعنوان Characterization and Properties of Dust. وسيرأس الجلسة Dr. Oleg Dubovik. We'd like to welcome you to the last session of the day. And it will the title of the session is the Characterization and Properties of Dust. It will be chaired by His Excellency Dr. Oleg Dubovik. So the floor is yours.
Okay, thank you very much for this opportunity to speak here and present my work. And from remote sensing, and I'll highlight some advances which we have by now, and also we'll talk about some challenges. Well, first of all, what are the principles of desert dust remote sensing? Basically, we know that desert dust, as any aerosol, consists of small particles, and apparently they change distribution of radiation in the atmosphere. And once we shape of the particle, we can understand differences between properties of aerosol particles changing that radiation. For example, for the very simple shape of the particle like spherical, we can very accurately model that redistribution of radiation. And therefore we can measure and characterize the aerosol and desert dust. And here you could see just a very basic scheme of main observation of the remote sensing observation of aerosol and desert dust from ground and satellite. And the very basic and kind of fundamental measurements of desert dust is observation of direct sun. Here we already heard a lot of discussion about ARANET measurements. And the direct sun observation, that was the very first and basic observation of aerosol and desert dust. As you could see, if you look directly at the sun, actually solar beam is extincted or radiation removed by aerosol from the incident solar beam. We can measure that. There is a like Booger-Lumber law, and if we look for the exponent, there is such a property like aerosol optical thickness in exponent, which considered as a main parameter of aerosol affecting radiation, and it relates to the total amount of aerosol. And if we look at the spectral dependence of this property, the desert dust has a tendency to have quite neutral optical thickness. That means, in effect, more or less similar all visible spectrum. And that's important difference from other aerosol type like a smoke or urban pollution. And, but if we try to interpret diffuse radiation observation, for example, if we scan using a sky radiometer of iron at the sky, we can get much more information about aerosol properties. However, we have to be able to model that radiation, which is not a very simple task, because we need to, first of all, be able to model scattering by single particles, depending on the size and morphology and shape, and also account for different effects of multiple scattering, like rescattering between particles, like accounting for gaseous absorption, molecular scattering, and surface reflection. So that's quite a challenging task, and basically the angular distribution of radiation depend on a so-called scattering matrix, which define angular distribution of intensity and polarization, and generally like interaction of electromagnetic light with the particles and changing of the Stokes vector, which describe those interactions. However, if we account that solar radiation is non-polarized, so basically Stokes vector equal 1 for intensity and 0 for other elements, we'll find that all remote sensing mostly depend on the angular distribution of intensity and degree of linear polarization. And here you could see, and the better we see that distribution, the more sensitivity we have to aerosol particle. And here you could see different type of observation and how they observe these angular ranges. For example, the Aeronet measurements, which are known to be one of most informative observation for detailed properties of aerosol in column, they observe like direct hemisphere of intensity and polarization, P11 and P12. But if you look at satellite data, they actually looking in back hemisphere. And I'll be today also talking about multi-angular polarimeters, which also cover pretty good range of scattering angle in back scattering. Now, if we looking what kind of information we can get measuring this direct and diffuse radiation, again we coming back to the Aeronet network, which is kind of a very essential source of our quantitative information about properties of aerosol in total column. And you could see that using both direct and diffuse radiation, we were able to set up retrieval algorithm which provide us detailed information about aerosol size and also optical properties like real imaginary part of refractive index, the spectral dependence, and which also control all optical properties, including absorption. For example, this is a pretty old paper, but it's kind of shows essence of the information which we can get from Aeronet observation. Here you could see climatology of main optical properties, specifically size distribution on the bottom and single scattering albedo on the top right, on the right side of the presentation. And it's shown for different type of aerosol, typical aerosol, like biomass burning, the smoke, urban industrial, specifically here you could look at the desert dust. And if we look if we zoom at the desert dust, you could see that desert dust size distribution generally bimodal, dominated by coarse particles with a radius between 2 and 3 microns. This is how Aeronet sees. There is some fine fraction, which is about 10 times smaller in volume than coarse fraction. And what's was very important, at least at that time, and it's still valuable information, that single scattering albedo, which characterizes ratio of total scattering to scattering plus extinction, is very high. That means close to 1. And that was probably first source of information, showed this, that desert dust really non-absorbing. And that's and defines the main property of desert dust. For example, for climate, it's mostly kind of contributed to cooling rather than forcing compared to black carbon. Now, how much different dust can be? Here you could see comparison of the Saharan and East Asian dust. And well, maybe it's not sufficiently representative climatology, but nonetheless, we could see that here dashed line corresponds Saharan dust and solid line is East Asian dust. And normally we see that East Asian dust slightly more absorbing, which is probably not surprising because the industrial activity probably much more intense in Asia. But at the same time, like on the right side, we could see that even for dust in different regions, we can see differences in absorption related with mineralogy. Probably it's a different content of iron oxide. And now if you look at size distribution, again, looking at African and East Asian dust, overall they are quite similar. There are some differences we can note, but they are not very essential. Seems like East Asian dust can be slightly larger, but I don't know if it's really statistically representative and has somewhat smaller fine mode. But nonetheless, the kind of the similarity of dust everywhere seems to be remarkable. And that's quite established information already. And even on this conference, you keep hearing Aranet, references to Aranet. And I think there are very little doubt that these results are quite solid and can be used in many applications. At the same time, recently, we found a challenge that there are a number of modeling and in situ studies indicate that there is like supercoarse sizes. I cannot show very clearly, but you could see this small third mode of dust for very coarse particles. And there are claims that aeronaut simply doesn't see those particles, although they exist. And the issue is that the optical contribution there maybe not very strong. That's why we may not see it. However, in terms of mass, it's very substantial part of the dust and may be important for a number of applications. This is why we kind of now conducting a study and trying to see really, can we see that part, that size distribution from Aranet? If not, why? And if we can, how we can improve that. And here it's maybe not very clear, but it's some result of our studies. Here you could see we put like regular, like dust which we see always in Solar Village, plus supercoarse dust, and we made the forward simulation. When we added supercoarse particles and made simulation and then inverted. We inverted first as Aranet does, and you could see the many curves, but basically I can tell you that once we implement a typical inversion, we can fit very well radiances. However, we cannot reproduce very well size distribution. It's somewhat shifted to smaller particles. But optically, it's almost equivalent. But then we decided, what if we extend the largest size of the particles to 35 micron? Would it actually help? Will we see some artifacts? Because due to lack of sensitivity, we expected to see strong artifacts. But when we extended, we actually could see that our retrieval pretty much captured those presence of super large particles, and at least we don't see a lot of artifacts. And here you could see some illustration. For example, on the top, on the left, you see that from inversion of real dust over Cape Verde. The upper left figure is just typical Aranet inversion, and on the bottom, it's an inversion with extended size range. And as you could see, retrieval not very different. However, we see some bit larger particles. And I think, at least from a viewpoint of modeler and in situ community, it looks nicer. And on the right side, you see 2 cases of retrieval over Dakar, where you could see it's inverted like typical AeroNet inversion and extended. And we can say that we can fit very well data, but extended retrieval with extended size range produce slightly larger particles, and that's probably will be a new modification in AeroNet retrieval if we find a full confirmation of this finding. Now, another subject I wanted to talk, you probably, those who are working a lot with remote sensing, you know that there is very high expectation from measurements of polarization. But basic AeroNet measurements, they do not use polarization that much. However, there are a number of instruments which do provide measurements of polarization. And I often hear the question if it's useful or not, and what kind of future we can suggest. And here you could see the typical measurements in China for 3 different cases, like fine mode aerosol, like mixed and desert dust, with polarization at 8 wavelengths. And you could just see the optical thickness, skyradiance, and degree of linear polarization. And then we implemented inversion, one like without accounting polarization and another one with accounting polarization, and we are looking what kind of effects we could see. And if eventually we see some positive changes, but mostly for fine mode particles, like on the left side, you could see, like I highlighted in kind of pink color, the changes. For example, we correct fine mode size distribution, shape, and also we correct real part of refractive index of fine mode. Once we have mixed aerosol, well, we have 2 modes, fine and coarse. Well, what we saw that observation with polarization very sensitive to the non-sphericity. If like dust is spherical, we immediately see, well, if aerosol is spherical, we immediately see polarization forces to show that particles are spherical. While without that, sensitivity for fine particle is not very strong. On the right part, you could see the results for desert dust. And apparently, there is no changes with polarization. That means for desert dust, it's clear desert dust cases, the measurements of polarization do not bring that much. And somewhere, when you think of the reason, it's not surprising. And I'll be talking about that bit late about reason. And reason is that desert dust actually very complex aerosol. And one of the important feature of this kind of aerosol is that it's composed by non-spherical particles. That means if we assume sphericity, it's probably not adequate model. And how do we model then desert dust? Right now in AeroNet, we use a model of polydispersed randomly oriented spheroids. And what does it do? You could see that on the left side, you could see phase function and degree of linear polarization of spheroids of different aspect ratio, and then they average over shapes. And you can see on the right side, like degree phase function and degree of linear polarization in blue for spherical particles for the same size distribution, same refractive index, and non-spherical. You could see that for phase function of non-spherical particles is flatter, and also all features from degree of linear polarization gone. And then that's important features we need to account. What happened if we don't? This is old paper, but it's still valid. For example, in the middle on the bottom, you could see in the red, which is a curve, it's a strong artifact, like we see for desert dust, are artificially high concentration of very fine particles. And on the right side, we see like very low real part of the refractive index. Those are artifacts which we used to see before when we didn't have proper accounting for particle non-sphericity. So if we would not account right now for not use spheroidal model, then that's what we'll get. And here you see another important feature that you could see, for example, why polarization is less efficient when we characterize dust. Here you could see the degree of linear polarization of spherical particles, fine, dominated by fine and coarse mode on the left and the right, and on the bottom you see same for spheroids. And as you can see for fine particles, we see that it's curves for different refractive index. We see that polarization is sensitive to refractive index, the curves are different. Once we go to coarse particles, for spherical particles we also see a lot of features, but for non-spherical everything is gone. And that's kind of logical because polarization is show very fine details in scattering which appear due to regularity of shape. But once we have non-spherical particles, they are all different, they are oriented differently, and you have all kind of averaging, so all fine features gone. So you cannot, basically, more precise measurements do not bring you anything because everything averaged. And this is why, for desert dust, polarization doesn't bring much. But on the other hand, if we have polarization, we have much better tool distinguish between fine and coarse particles, so that's at the end still bring a lot of benefits for the desert dust remote sensing and characterization. Another measurements where particle shape is very important, it's observation of LiDAR. And these measurements kind of main source of information about vertical variability of aerosol. Like here you could see illustration for Calypso. But if you look, for example, at observation from ground with LiDAR, it's on one wavelength. It's basically here, well, it's equation, but it's dependent on two values, one extinction and another so-called LiDAR ratio. So in order to get something from the one measurement, we need to assume one or another. And usually LiDAR ratio characterizes aerosol type. So if you know aerosol type, here on the right we can fix it. And then we can get an extinction profile. But as you could see, as I showed on the right side, that LiDAR ratio strongly depends on particle shape. For desert dust, for example, if we put spherical particles, LiDAR ratio way smaller than for spheroid and for non-spherical particles. So if you don't account for that, we'll have strong artifact. Another important feature is depolarization ratio. If our initial LiDAR beam is polarized, the return signal will be depolarized. And here it's dependent on element P22. For spherical particles, absolutely 1, so that means you send polarized beam, you get fully polarized beam. But if particles non-spherical, you get depolarized beam. And depolarization is a really indicator of non-spherical particles, and we have to be able to model that. And with spheroids, we can do that. However, those who work in the remote sensing, you know that spheroids, sometimes there is some skepticism in the community about spheroids because it seems like the simplest non-spherical shape. And if you look at really like photos of desert dust, the particles do not look like spheroids. Therefore, there is always search for more complex models. And here I showed you two candidates of that. One is so-called superspheroids. Superspheroids, I mean, spheroids, it's a rotational ellipsoid, and they change from spherical particles like to prolate or oblate, depending on axis ratio. Superspheroids, there is extra dimension with so-called roundness. And you could see, like, from spheroids, you can go to different roundness and get particles of more complex shape. So there is kind of extra dimension. Another candidate, it's hexadrons. You could see the picture there, and basically now there are databases for both superspheroids and hexadrons which we can use and evaluate how much they are better, how much they are different. And apparently, here you could see, we took same size distribution and took different models like spheroids, which we used to, superspheroids and hexadrons, and calculated main properties like phase function here on the left, degree of linear polarization, and element P22 which define depolarization. And apparently the differences are very small. So these complex shapes apparently do not change dramatically scattering. The only difference which kind of desirable was for depolarization. But anyway, this is a preliminary results. We keep looking at that. But the main message that even changing strongly shape not necessarily will bring something revolutionary changes to the remote sensing. And my last discussion would be, last part of discussion will be, it's about satellite remote sensing, specifically about multi-angular polarimetric observation. And I'm sure Bertrand Fournier from EUMETSAT will be talking about that also. But why I'm talking about that? Because I think this is a kind of most promising passive remote sensing type of observation which we'll have in the future, and I believe it will really improve our ability to characterize aerosol overall and desert dust in particular. And why? Because, like I already mentioned, maybe it was not very clear, but basically information content of our measurements depend how well we can see angular variability of phase function or degree of linear polarization. And with single view observation like MODIS, you could see only 1 point. So that means we don't have much sensitivity there, especially thinking that also surface contribute a lot to our observation. But with multi-angular polarimeter, we cover pretty large angular range both for intensity and polarization and backscattering, and normally sensitivity much higher. And another aspect, that main difficulty to distinguish aerosol contribution from satellite is to distinguish contribution of underlying surface and atmosphere in the satellite signal. When we make measurements with IronNet, why it's so valuable, why it's so bring so much information? Because they're not affected by anything else but atmosphere. From satellite situation difference. Often surface signal is dominates. And here on the bottom you could see, I showed you a contribution to the satellite signal from surface and compared to desert dust and smoke contribution over bright surfaces. As you could see, black line, which is surface, is much stronger. That means basically what we see from satellite is surface contribution. However, once we look in polarization of the surface, we know that land is kind of irregular and doesn't polarize. So you could see on the right figure on the bottom that basically our contribution of aerosol, particularly smoke, small particles, much stronger than surface. And dust also stronger, however, not much. Not as much. Why? Again, because desert dust non-spherical, it doesn't polarize itself. But nonetheless, still the polarization helpful. And here the results of illustration of our processing of past multi-angular parametric data of polder parasol. We now have like a number, maybe 4 different products from this observation generated by algorithm called GRASP, Generalized Retrieval of Aerosol and Surface Property. This is actually kind of strongly evolved IronNet algorithm, which has been more elaborated more and applied also to many other remote sensing observation, including multi-angular polarimetry. But what extra we can get? First, we get many more detailed parameters. We can get optical thickness, spectral, optical thickness, fine and coarse mode, and Strom exponent absorption and detailed properties of land surface. And there I emphasized that here, once we do retrieval, we try to minimize all kind of a priori assumption and local specific assumption. We even initial guess we have globally the same. So basically what we get, it's mostly driven by observation. And here, well, just illustration, global validation for 1 year over land, total optical thickness, and Strom exponent, aerosol optical thickness, fine and coarse mode. And I mean, I don't know how familiar you are, but you can believe me that these results quite kind of convincing. Especially, I would like to emphasize, like we can get detailed properties. For example, here on the left, you could see just aerosol optical thickness over Africa, like in winter and spring. You see there is it's a monthly average. You see there is a strong outbreak of aerosol. It's looked the same. However, if you look at the second figure, where there is Strom exponent, and Strom exponent indicates the low value, indicates more or less dust, and higher value, which is yellow, it indicates fine particles. And as you can see, apparently this aerosol very different. And during spring, it's dominated by desert dust. In winter, there is significant biomass burning. And this is what we can see from our retrieval from polder. You would say that we can see that from MODIS, but that's not really true. Just nobody look at that. For example, here on the bottom, you could see validation of extreme exponent over land for MODIS on the left and on the bottom, and for Parasol. You see the Parasol is much better. And on the top left side, you could see global correlation between Polder, which we consider like provide reliable Angstrom, against MODIS, or MODIS against Polder. And as you can see, this funny feature that there is, well, kind of marginal correlation, but you could see this funny stripe structure, which shows that basically Angstrom exponent fixed regionally for MODIS. So we don't have that information. And if you think that it's still okay, here is example of like observation in September of where we know that there is very strong smoke event over Africa, and you could see optical thickness from MODIS and Polder on the top, kind of comparable. But if you on the middle part of slide, you could see Angstrom exponent, and you could see that for Polder on the right side, it's kind of a nice transition from the land to ocean, while from MODIS there is small particles over land and coarse over ocean. And if you look at coarse mode, coarse mode aerosol over ocean, on the below you could see that MODIS show coarse mode aerosol where it should be smoke. So that's basically failure. We don't have that failure with multi-angular polarimetry. And moreover, we find that there is even more advanced way to explore this data. For example, this is new approach where we try to retrieve not like in IRONET size distribution and refractive index, but we assume that each aerosol consists of different chemical components, and we retrieve fraction. For example, like here, there is fine coat mode composed of black carbon, brown carbon, non-absorbent soluble, non-absorbent insoluble, and there is also different composition for coarse mode, like ferrum oxide, coarse dust, and so on. And as a result, when we get retrieval, we get, for example, here you could see distribution of coarse dust, iron oxide, which indicates absorption of dust and different type of aerosol. And that's new information. However, if you look at same optical properties, they're even better than what we get by traditional method. Like here, you just could see correlation of optical thickness and Angstrom exponent and single slit albedo. And finally, what do we do with our retrieval results once we get them? And here, just quick illustration that normally, of course, we try to feed the assimilate the information into models and try to make our models more realistic. And here was just quick illustration how we did this kind of exercise with our Polder observation. We basically took optical thickness at 6 wavelengths and absorption optical thickness at 6 wavelengths and feed it for 6 years by GeoSchem model by adjusting emission for black carbon, organic carbon, and their desert dust. And here on the left, you could see like very left column, it was our observation of absorption over Africa. In the middle, it was what was modeled by model initially, and on the right, how well our fitted measurements reproduce the observation. And doing that, we retrieve emission, and apparently we found that black carbon and organic carbon were strongly underestimated, but however, desert dust was overestimated by 40%. And if we compare to any other satellite, like for example, we used the initial model compared to Parasol, and you see the red color shows that model overestimate dust very strongly compared to Parasol, and then compared to MODIS and compared to MISER. Once we replace our emission, as you could see on the bottom, the agreement is much better. And here, just quick illustration, we use this emission to simulate direct radiative forcing. And just illustration, like you could see overall, the blue means cooling, the red means heating, and overall aerosol is cooling. And while especially, but the black carbon, for example, heating very strongly, while desert dust on the bottom normally cools the atmosphere. And this is our overall estimation for like direct radiative forcing, the paper published in Nature Communication in 2022. and you could see that our estimation of aerosol effect, well, how they agree with other measurements, and basically they show that aerosol cool a little bit less, but our uncertainty seems to be much smaller than other studies. But if you look here on the top over Sahara and Saudi Arabia, we still see that climate aerosol kind of heating, probably because the surface is very bright and overall there is still some aerosol absorption. And thank you very much. Here I stop. If you have any question. Any questions? Or we move on? Yeah, okay. We then move on to next speaker. And I don't have program. Yeah, I think it's Stefan Victory from CIMEL. How do we change the presentation here? No, that's my presentation. Yeah, okay, but how do we change? How, we need presentation switched.
And how do you, comment to change?
Well, this change. Okay. Don't push this because it's the micro.
Okay. Thank you. Yes, okay. Oh, good. Yeah. Thank you, Oleg. So I'm Stefan Victory. I'm working in Agora Lab, which is a common lab including CIMEL Electronic, a French company, manufacturer for LiDAR and photometers, and LOA, a French lab based in Lille. Yeah, our ecosystem in Agora is based on collaboration with different institutes and companies, including GRASP, Latmos, manufacturers of LiDAR system, Onera, an institution in France mainly focused on optical design, IMET for the validation of and calibration of photometers, Actris, which is a European center for aerosol monitoring, both in situ and remote sensing, and we are involved in CARS, the Centers for Aerosol Monitoring. Of course, NASA in the frame of AeroNet network, because we provide the photometer, and the LabX Kappa for instrument synergy, so combination between different instruments. The main strategy that we have to try to classify and to identify particles is the combination between different instruments. And the main idea is that the more information we have, the more we can classify particles, we can type the particles. And so we have developed two different strategies. The first one, two different approaches, sorry. The first one is based on the existing photometers, the CIMEL photometer, which equips the AeroNet network, yes, and the MicroPulse LiDAR CE376. And the combination of the two instruments is called the AMS Automated Aerosol Monitoring System, and this is what we push. So this system is based on the existing photometer instrument, and we can add a MicroPulse LiDAR. It's a two-wavelength LiDAR. The second approach is based on high-power LiDAR using Mie scattering, Raman scattering, and now the fluorescence of aerosols. And we will see the difference between the two systems, and that's it. Just an example, so for the first approach, I just said that we combined photometers and MicroPulse LiDAR. So here are the information on the photometers, the AeroNet photometer provided by CIMEL. For aerosol study, we have mainly two different systems, the standard system, the TS9, and the TP9 for the polarization measurement. And they have the same wavelengths, except that the TP9 has polarization measurement. And you can see on the bottom left an example of Audi data here in Riyadh Airport in 2023, so that's an AeroNet data. And on the right part of the picture, you see the calibration center facility in Goddard at NASA Washington Center. For the first approach, we combined with the MicroPulse LiDAR we have a set of different versions of this LiDAR, but the one dedicated to aerosol measurement is the GPN version. It contains 2 laser systems, so 532 nanometers and 808 nanometers. And the system is a micropulse system, so very low energy, continuous measurement, 24 hours a day, 36 all year long. And for difficult environment, we can also provide a thermal enclosure that can work between -30 up to 55 degrees. And if we look at the AeroNet network in the local scale and regional scale, you can see on the left picture that there are quite a lot of photometers, AeroNet photometers. And if you look at the local scale at near Saudi Arabia, you see still there are some photometers. And one of the first approach will be, for example, to add some micropulse LiDAR here to be able to combine the data. And combining the data means getting some what we call a quick look like this. This is a quick look obtained in Lille, in the north of France, for 1 week. So it's continuous monitoring, continuous acquisition of the two systems. And just on post-processing, what you can get is you can identify cirrus cloud, saran dust, indirect pollution, urban pollution on the right, also aerosol volcanic ashes. This is just on 1 week acquisition data in Lille. So there are a lot of information when you start combining photometer and LiDAR system. The standard output is listed on the bottom. So we have the range corrected signal, depolarization at 532, extinction and backscattering coefficient. And if you go a little bit further, combining the 2 wavelengths of the LiDAR, you can get what we call a color ratio or vertical profile of angstrom exponent. And also, if you have you make some assumption on the aerosol density, then you can get the PM2.5, PM10 concentration, also separate in fine and coarse mode concentration. That's what we can get on post-processing. But you can also do this in live scan, so continuous running, the data are acquired continuously, and you get this kind of software acquisition. This is our software. So on the top, you have the extinction profile given by the LiDAR at 532 nanometers. On the bottom, you have the aerosol optical depth at different wavelengths. On the bottom, complete bottom, you have the water vapor content given by the photometer analysis. And combining these with the volume size distribution given by AeroNet or given by GRASP, because we have GRASP inside the software, you can get on the left, top left, an example of PM10 concentration vertical profile. That's a continuous live acquisition. So that's quite amazing. Now, if I switch to the second approach based on the high power LiDAR, so here we are talking about Mie scattering, Raman scattering of molecules, and also what we recently added is the fluorescence of aerosols. And we are fully following the ACTRIS mandatory requirement and even going beyond that. So of course they ask for 3 wavelengths, for 355, 532, 1064, depolarization, so we can provide all this. The height resolution is supposed to be less than 50 meters, but we can go to 3.75 meters. Even it's not very important. And about the features, we satisfy most of the features recommended by ACTRIS. Talking about the instruments, the laser source, now we need power, so we need high power laser. Our suppliers is Lumibird Laser. It's a French company based in the south of Paris. And we are using either flash lamp laser or diode pump solid state laser. What is important to get enough signal in the fluorescence of the aerosol is to have energy. So we put, for example, a 260 millijoule, 100 hertz diode pump solid state laser that can emit this energy at the 3 laser wavelength, 355, 532, 1064. So that's a lot of energy. The consequence of this is that for the beam expander that collimate the beam, we have to separate the UV channel and the other channels. So that's an example of the 3D design. Another point on the instrument, so it's a telescope, a 40 centimeter diameter telescope, so you can get a lot of signal back. It's a cardboard made, so it's a really rich instrument. And for the analyzer part, the idea was to have a kind of Lego structure. So we have a unit cell where you can put anything, a filter, a beam splitter, anything inside, and the user can set up its own design to get up to 15 different channels. So I recall you that we can emit 3 laser wavelengths, but we can get up to 15 channels, including Raman and fluorescence channels. That's what I'm going to show just later. This is, for example, one of the many examples that we have of these instruments. So we have me and depolarization channel at 355, 532, and 1064 nanometers channel. So it makes already 6 channels. We can add the Raman, both vibrational and rotational channels to get the extension and the backscattering coefficient. And then what we recently add is the fluorescence channel. So we have a long list of fluorescence channels. And you have an example on the left of one of the designs that we can make. So the strategy about this fluorescence is that we need to measure the fluorescence. And you have an example of on the left side of the shape of the fluorescence signal. So we all know about the Me profile, the Raman profile, the efficiency of that. But if you look at the fluorescence, it's even less. So what we call the fluorescence capacity is much lower than the elastic one. So this is, and if you look at the spectrum, it's very large. So in a short bandpass filter, you need a lot, you need to have a lot of energy for the laser to be able to measure something in backscattered. And this is what we define the fluorescence capacity. And you see that it's a ratio between the fluorescence and the elastic. And you see that it's in the order of 10 to the power -4. So you need a lot of energy, and so you need a big LiDAR. But what is interesting, and this is the main slide of my presentation, is that we can do typing using the fluorescence, because every aerosol emits fluorescence. Whatever the type it is, it has fluorescence. So one of the examples is a paper published by Igor Velezovsky, which is in the team, is that just using the depolarization at 532 and the fluorescence capacity, we can do identification of the particle. And you see on the right side that the particle depolarization versus the fluorescence capacity. And there are areas where it's only dust, pollen, urban, and smoke. Of course, you can mix that. But we can do identification just using this LiDAR and the fluorescence. Another example by Igor Veselovsky is this. So we developed this quick look analysis software. And there are 4 examples in Lille, north of France, where we have events containing smoke and urban, smoke and pollen on the September 2020. And on 2022, there was a combination between dust, smoke, and urban pollution. So we can do this almost in live mode right now. Another thing that we have done very recently is published by Igor Velezovsky too again, is that we have shown that some of the measurements published in the literature about water vapor measurement are wrong, because as we said before, the fluorescence exists. All the aerosols emit fluorescence, and some of this signal is detected in the water vapor Raman channels. So if you're not able to correct this, you may overestimate the water vapor content that you have in the atmosphere. So this is a design, optical design, that we have done to separate the contribution of the water vapor and the fluorescence in the water vapor channel system. So the main idea is to use depolarization, because the depolarization of water is completely different than the one of the fluorescence. The fluorescence is much bigger. So we can separate and get the real water vapor content. The next step, this is something that we're looking for the future, is now to try to combine the high-power LiDAR that I've just shown and also the multispectral measurement given by the photometer. This is something we are working on, and we will rely on GRASP software to do this. The goal, of course, being to get the vertical distribution of particle concentration, but by type of particle. That's the goal, what we want to do. Thank you for supporting. Thank you.
Okay, thank you, Stefan. Since we are moving all questions to the discussion session, the next presenter will be Dr. Amar Hassan El-Mamam. and he will be talking about accuracy assessment of several, no, not him. Sorry. Mizama Geo Observatory capability to monitor dust storm from the geostationary orbit. Please go ahead.
Thank you so much. Thank you. It's my pleasure to be here and to present at this really amazing conference, very informative and very well organized. Before I start, I'd like to convey a message from Dr. Ali Omar, who is the Deputy Director of the Langley Space Center in NASA, who was unable to attend. He was supposed to share with me the presentation, as he's the scientist and I'm the space technology person, so don't ask any difficult questions on science, please. So I would like to start by introducing our organization, which is called Intospace, International Outer Space Association. It's a non-for-profit organization set up in the UK, and we hope soon we will be able to set up also here in Saudi. And its aim really is to initiate and realize projects which are international and involve cooperation between many countries with common aim of looking and focusing at the Earth, its environment and sustainability. I shall not go through all these slides because we don't have much time, but I'm sure it will be there on the system that you can then look at. So next slide. Just very briefly to say that we already have an extensive list of experts who have joined this association from different organizations who are prepared to voluntarily, at least initially, to support our efforts. And then the idea is that once we are able to initiate these projects, then of course we run them as proper activities, just as we would do, say, if we were ESA or NASA. So we're not trying to take over from agencies, but we're trying to complement and support agencies in areas where maybe they have slowness in starting these projects. So, the program I want to talk to you about, which is relevant to our discussions in this event, is the Miasma Observatory Program. So Miasma stands for Middle East and Africa Space-Based Monitoring of Atmospheric Pollution. And Miasma, just by coincidence or maybe foresight, also stands for polluted air in Greek and Latin, but also in Arabic, I've looked in the dictionary, al-Miasma also refers to polluted air. This program consists of two sections or two elements. There is the Miasma Geo, which is effectively similar to a TEMPO instrument and also GEMS instrument. So the TEMPO is a NASA instrument and the GEMS is a South Korean instrument that is in a geostationary orbit that allows it to constantly monitor the large area on the ground and able to then look at atmospheric constituents, including aerosols, in particular dust. The other element is the LEO, which is the Low Earth Orbit Constellation, and this allows you to look at the atmosphere in a vertical tangent, so you can slice the atmosphere into layers of 3 kilometers. And I was privileged to be the electronics team lead for this development of the instruments at Rutherford Appleton Labs in the UK under ESA contract. So what is the challenge? So as you can see from the image on the left, this is an image from CEOS, the Community for Earth Observation Satellites. They've obviously identified there is a big gap in Africa, South America, and also Australia for such sort of monitoring from the geostationary orbit. The advantage of being in geostationary orbit is because you're obviously staring at the same point all the time, you can potentially have a revisit time of less than 1 hour, which means potentially you can look at the changes of the atmosphere and its constituents on an hourly basis. As you can see on the right, this information can be seen from a number of satellites, for example, from the satellites that are managed by EUMETSAT. But in this case, for example, it's mainly RGB that allow us to look at this hourly variations, and it will really only give you a subjective view of the sound and not much more than that. So, this concept of the Miasma Geo was initially proposed by Dr. Raed Soleimani. He is a researcher and a co-PI for the TEMPO instrument based in Harvard Smithsonian, and he suggested that we should have such an instrument over the region, specifically as we need to host this on a commercial communication satellite system. There are at least 3 such companies well established in the region, such as Arabsat in Saudi, Nilesat and Sahelsat, who have regular flights or launches of satellites into geostationary orbit. So we are under discussion with them to see who might be willing to host such an instrument. From a science point of view, and again, as said, Dr. Ali Omar is not here with me to support this, it can clearly cover the spectral range that is relevant to monitoring the various atmospheric constituents, and in particular gas, as it allows us to look at the aerosol absorption index in the very low ultraviolet, sort of 300 nanometer range. And as said, we are able to monitor all these constituents on an hourly basis. So more or less real time. And the proposed design for the instrument is very similar to TEMPO. The idea is that we just reuse the same technology to minimize the risk. Of course, we may need to change the optics and maybe the detector range of coverage, depending on the discussions we will have through the SAG, the Science Advisory Group. And I shall be discussing with many of you here to see if we can invite you to join the Science Advisory Group for this project, because the input of the end users such as yourselves is really crucial to be able to define a good instrument that will help us achieve the objectives for the region. Each region has a different sort of requirements, especially in terms of dust, as we've heard in the different presentations. So I will, well, I think you're all clear from the previous presentations what is the advantages of remote sensing for dust, but clearly this instrument, the Miasma Geo, will be able to allow to achieve many of these objectives, such as being able to monitor dust mobility, the dust storm evolution, but also, of course, to try to trace back the origin of the dust storms and its mobility literally on an hourly basis. The instrument, I will not go on too much in detail, but the instrument is quite large. As you can see, just the instrument itself is 1 meter cube. It's about 150 kilograms in mass and quite a lot of power. But as it is really amazing in terms of its performance, it can measure in the range of 290 to 490 nanometer band. And there's another band which is 540 to 740 nanometer, with a really amazing resolution of 0.6 nanometers. So it'll allow you to really look at the spectral lines and be able to differentiate closely adjacent lines really well. And this, as you can see in the figure, this instrument will actually sit onto a satellite. In this case, of course, it's an illustration of TEMPO. It's actual pictures of TEMPO, and the bottom figure shows how it is integrated to the Intelsat satellite. It's a very large satellite, of course. It's like almost a double-decker bus. So this is, the instrument is based on what we call CCD, charge-coupled devices, which is specifically manufactured to allow us to be sensitive to the ultraviolet and the visible range that is of interest to this instrument. And it uses the scan brush technique to be able to sweep across from east to west or west to east across the whole region of interest to allow us to get very good spatial resolution. So with this instrument, we should be able to get something like 2 kilometers by 5 kilometers per pixel, per element of information across the whole range. So effectively, the reason why these sort of bands were chosen is so that it's consistent with other instruments already flying, such as the Sentinel 5P, so the particular Troponia instrument, and also Aura, the OMI instrument, and both allow you to do the absorption index, aerosol absorption index in this sort of 300 nanometer band. And so we were able to achieve the same products, level 2 products, that match these instruments. And as you can see, this is a picture of from courtesy of Sentinel-5, but of course this is only a daily revisit, so you can only get this information sweep across every day, and it's not able to do this hourly as we're proposing with the instrument that we plan to develop. So effectively, it allows to calculate the absorption aerosol index, as I said, and look at the UV and visible aerosol depth, optical depth, and also the scattering albedo. So here on the left, I've got this image, which is a simulation that courtesy of the Dust Monitoring Office in Barcelona in Spain, and it's based on a collective of data from different satellites, and they use that to generate a simulation model. And you can see this is like stepping every hour. Now on the right, this is actually real data that we received from GEMS, which is, as said, identical to, very similar to Tempo. And you can see now here, it's almost real time. This is not simulated data on the right, but it's actually real data captured from GEMS. And Tempo will do the same over US. And of course, we hope that Miasma Geo, when it's done, it will do the same thing, covering over the Middle East and Africa. So this was effectively a description of the space segment, and the ground segment is really essential for this, and this is what we hope to start in the first phase of this program, is to install such monitoring stations as was described earlier in by many speakers, so I will not go through this, and be part of a network, possibly Pandora, for example, that will allow us to train and educate the scientists and experts in the region on how to use the data from such a satellite instrument, so that when we come to be able to have this satellite, which we hope maybe by 2030, then we have already the expertise to be able straight away use this data and include it into the modeling of meteorological modeling as well as the dust storm monitoring. So as you can see here, we aim to fill this gap that I showed you earlier with the Miasma Geo-N, which is effectively covering the Middle East and North Africa. And there's also a plan to talk about Miasma Geo-S, which covers from south of the equator, from the equator down to the southern tip of Africa. And we had a discussion and presentations with the CEOS, where they have a lot of interest in setting up a virtual constellation that collects all these different satellites that are existing and the ones we hope to launch soon, and have a virtual data center that will then integrate and fuse all this data together, including the ground-based data information from the monitoring stations. Our aim, of course, is by setting Intospace here, we also would like to then set up this center here in Saudi, because it's really, as you can see, very central to globally in terms of where it's located geographically. But of course, it will be really good to have that for the Miasma Geo. And the CEOS group are very keen to see how that progresses. So we hope it will be realized.
You have 2 minutes now.
Yes, I'm almost done. Thank you. So that's really it. I will not go through the Miasma Leo, but it's basically what we call a CubeSat system. And as I said, I was lucky to be involved in developing this instrument. This uses solar occultation with a technique called laser heterodyne spectroscopy. This is effectively allow you to then measure in the 8 micrometer band, but also it has a hyperspectral imager in the near infrared band with 16 channels. So that's really all I wanted to say, and thank you so much for listening. And if you have any questions, please come and see me, and hopefully you will also then ask during the panel session. Thank you.
Thank you very much. We'll have questions after in session for that. And next presenter is Dr. Ala Mahwish, our very energetic organizer of this nice conference. And he will be talking about accuracy assessment of several satellite-based aerosol algorithms for desert dust region of North Africa and Middle East. Please go ahead.
Thank you, Dr. Oleg. Today I'm going to present very common practice about aerosol validation over our region. Most of the validation study conducted over a globe. So over our region, very limited limitation study have been conducted in comprehensive way. So this is the outline of my presentation. So it has been many times defined the aerosols, which is tiny particles. Everyone, I think in this conference know that. So the aerosol optical depth is the integration of aerosol from ground to the top of atmosphere. Angstrom exponent, as many of the speakers has mentioned, it is size parameter. We can identify the aerosol size based on the angstrom exponent value. So we heard many speakers discuss about Aeronet, and one of the key parameters of Aeronet, it is provide accurate and informative information about aerosol optical and microphysical properties. We use it to identify the aerosol type, aerosol optical, microphysical properties, and also we use it to validate satellite products. It has high temporal resolution, low geographical coverage, and it's relatively costly and and need some maintenance. So aerosol measurement from satellite. Today I'm going to discuss about different satellite products, mainly MODIS, MISR, and VRS. Okay, I will go to the results. What's the major feature of MISR? It has 9 cameras. It is orbital satellite, low orbit satellite on board of Terra satellite. These sensors have 9 cameras looking at the same objective. So it provides more information compared to the one view angle satellite. So major limitation of MISR, it's lower spatial coverage compared to MODIS satellite and VRS satellite. This is very general information. So several algorithms have been used, MODIS measurements to retrieve aerosol optical depth, which is the major aerosol parameter we can retrieve from single view angle satellite. So also MISR satellite has a newly developed or newly version of the algorithm, which is higher resolution at 4.4 kilometers. So it retrieves different aerosol parameters such as total aerosol optical depth, small mode aerosol optical depth at a cutoff of 0.35 micrometer, medium and coarse mode optical depth, and also provide information about non-spherical aerosol optical depth, which is very useful over our region because most of the dust particles are in non-spherical shape. MISR also has 74 aerosol models in the lookup table, so it provides more information about optical and microphysical properties. The spatial resolution of this algorithm is 4.4 kilometers. Deep Blue algorithm, it has been used to retrieve aerosol optical depth from VIRIS satellite, from MODIS satellite. It's the second version or second generation of this algorithm, can retrieve aerosol over bright surfaces and over dark surfaces. The spatial resolution of Deep Blue algorithm, which applied to MODIS satellite, it's 10 kilometer resolution, and for VRS it's 6 kilometer resolution. MAYAC algorithm, it's relatively high resolution algorithm, developed I think in 2008-9. This algorithm currently operational on MODIS satellite and provide aerosol optical depth at 1 kilometer resolution. So what makes aerosol retrieval over our region, over North Africa and Middle East challenges? As Dr. Oleg mentioned, the bright surfaces is very challenging to retrieve aerosol optical depth over because the signal reflected from the surface is very high. Okay, so it's very difficult to remove the surface signal from the top of atmosphere reflectance. Also, the surface heterogeneity, sometimes it creates biases in the retrieval. And aerosol type, you know, this region, it's developing very fast. And different aerosol type are introducing to the atmosphere. So the mixing ratio between dust and other type of aerosols makes the AOD retrieval over this region a bit challenging. So our analysis we conducted the analysis from 2002 to 2022 for MODIS and VIRIS and MISER. So we use high quality aerosol optical depth from MODIS, MISER and MIAC. Here we interpolate the aeronet data from 500 nanometer to 550 to match the aerosol optical depth retrieved by satellite. The methods we used around 23 aeronet station, data obtained from 23 aeronet station, and we compared it with MISER, MODIS, MIAC, and DBBLUE algorithm. But here what we have done is to compare the aerosol optical depth at different scenarios. At low aerosol loading, where the signal from the surface is very high compared than high aerosol loading. Okay. So, sorry for that. So we conducted this retrieval at different aerosol load when the aerosol in the atmosphere is relatively low, less than 0.2, and at aerosol loading more than 0.2. So at aerosol loading more than 0.2, the most of the contribution come from aerosols, and the aerosol model, which is saved in lookup table, has a major role in aerosol retrieval accuracy. And aerosol type, when the aerosol is fine, based on the angstrom exponent, which has angstrom exponent relatively 1.2 and more, and when mixed aerosol from 0.7 to 1.2, and at coarse aerosol type, and then we check the seasonality in AOD retrieval. So this is the logic by comparing the satellite and ground observation. It's just making collocations, spatially and temporal collocations. So the satellite flow over the region, and on the time, over past time of the satellite, we compare with ground observation. What we have done is to average 3 by 3 pixels around the aeronet station, so to get more collocations between satellite and aeronet. So the evaluation metric, we use different statistical evaluation metric, root mean square error, root absolute error, correlation coefficient, and expected error. We use the expected error, it's 0.05 multiplied by 15%, which is generally the envelope where contains plus minus 1 sigma standard. So this is the evaluation, general evaluation, comparing satellite observation with ground observation. The first figure on the left up, it's the comparison between MISER and aeronet data, and we see like it is pretty good correlation with around 0.86 R, and the points which is falling with the expected error around 71%. When we compare it with MODIS DBBLUE, the MODIS DBBLUE provide more collocations because the spatial coverage is MODIS is higher than MISER. It's around, like if you compare, it's around 5,000 collocation from MISER, and from DBBLUE it's around 22,000. So the spatial coverage of MODIS is more, but the accuracy of MODIS DBBLUE it's less. So the R squared is the R is 0.78, and the number of collocation within falling within the expected error, it's around 57%. Coming to the same algorithm applied on VRS algorithm, we find relatively better performance compared to MODIS at 10 kilometers, which is maybe due to the higher spatial resolution. Coming to the MIAC, very high spatial resolution, 1 kilometer, it significantly underestimates the aerosol optical depth, especially at high aerosol loading. This we will go in details. So it's around 0.77, and the retrieval below the expected error around 46%. So now we want to check the dependence of retrieval error and aerosol load. So at low aerosol load, the contribution from the surface reflectance is high, and with increasing the aerosol load, the contribution from the aerosol models become more significant. For Miser, we can see there is significant, relatively high underestimate at aerosol optical depth greater 0.8, but below 0.8, the distribution of bias, it's relatively okay, and the mean bias or the median of the bias, it's around 0. Compared to MAYAC, at low aerosol loading, 0.2, it's okay, going fine, and with increasing the aerosol load in the atmosphere, it shows significantly underestimation of aerosol optical depth. Similarly, VRS and DB Blue, it shows relatively, VRS, it's performed better than DB Blue algorithm at high aerosol loading. Now, a different aerosol type. We have mentioned for angstrom exponent value less than 0.7, it's considered as a coarse mode aerosols. And between 0.7 to 1.3, it is mixed aerosol, and greater than 1.3, it is fine aerosols mood dominated. So for Miser algorithm, we can see in coarse mode, the bias is relatively positive bias, okay? Means it's overestimate the aerosol optical depth during the dominated dust aerosols, and while with increasing the fine aerosols in the atmosphere, it's getting negative bias. The figures on the right side, it shows the size distribution of aerosol obtained from Aeronet. So we can see during summer and spring, it's coarse mode dominated aerosols, and during autumn and winter, relatively less smoke, less dust aerosols in the atmosphere. In this comparison, we find R, it's around 0.88, which is relatively very good compared to MAYAC. MAYAC, it's high resolution, but it's relatively underestimate aerosol optical depth for coarse and fine and mixed aerosol type. So for coarse aerosol type, significantly negative bias. Okay, coarse aerosol means, in our region, means dust. So MAYAC underestimate the dust aerosol optical depth in our region, and the bias becoming less negative with increasing the fine particles in the atmosphere. In the right-hand side, we can see that during spring and summer, the high dominance of aerosol optical depth dominated by coarse mode, it shows very high negative bias. Going to the next slide, yes. For VRS, relatively performed better than MAYAC. Okay, and it shows 0.001 bias for coarse mode and negative bias for fine mode. This is also similar for DB Blue. So the seasonality, it shows there is significant variation in retrieval accuracy between the seasons. So the summer seasons and the summer seasons and spring seasons is dominated by coarse mode. So we see the MAYAC, it significantly underestimate the aerosol optical depth during summer and spring, while Miser, it shows better performance in all seasons except in summer, which is relatively 64% of the retrieval falling within the expected error. VRS and DB Blue relatively performing same. So this figure shows the aerosol optical depth obtained from Miser algorithm. It's for 20 years average during winter, spring, summer, and autumn. This is the first row. It shows the total aerosol optical depth. In the second row, it shows the non-spherical aerosol optical depth. Non-spherical aerosol optical depth, we can consider it as dust particles. So we can see in spring and in summer, the high aerosol optical depth match with the non-spherical aerosol optical depth during post-season. So what we can say, the contribution of dust particles to the total aerosol load during those seasons is very high in North Africa and Middle East. So the third row, it shows the fraction aerosol optical depth obtained from MISER. So shows the small aerosol optical depth when the cutoff is less than 0.03 micrometer, and for medium and for coarse aerosols. We can see in winter and in autumn the contribution of small particles to the total aerosol optical depth is higher, while in summer and spring the contribution of aerosol optical depth, the coarse aerosol optical depth, is higher compared to other sizes. This is over Arabian Peninsula or over Middle East. We can see the aerosol optical depth is very high in summer, which is around 0.4, and in spring 0.3. This data obtained also from MISER, which shows very high accuracy compared to other algorithms. In winter and in autumn, relatively lower than summer and spring. For non-spherical aerosol optical depth, which is mainly dust, in spring and in summer, higher compare winter and autumn, as you see in these figures. This is the coarse mode aerosols over Ar-Rab' al-Khali. It's very high in summer and in spring, and in winter also it shows relatively lower compared to those seasons. The radius of aerosol optical depth for the coarse particles, it's greater than 0.7 in this MISER algorithm. For the medium size, which is between 0.35 to 0.7, it shows high in Rab' al-Khali, in Oman, also in big part of Iraq. For fine mode, which is relatively higher also in summer and in spring, okay, but also we can see the high small aerosol optical depth in autumn in Rab' al-Khali and in eastern part of Saudi Arabia. The radius, the effective radius of the aerosol optical depth is less than 0.35. Conclusion. So what I can conclude is, in this region, actually, we need more ground observation to tune the aerosol retrieval algorithm. We need to know more about optical and microphysical properties. And optical and microphysical properties of aerosols, I believe it's changing through the time, because these countries are developing very fast, and more aerosol types are introducing to the atmosphere. So not only dust, there's another aerosol type, and so the mixing ratio of aerosols changes with time. Also, more regional aerosol, more regional evaluation studies required to improve the aerosol retrieval over this region. Because most of the decision makers, they are taking their decision based on aerosols, based on satellite retrieval, which is relatively, some algorithm shows bad retrieval over this region. Thank you very much.
Thank you very much, Ella. And we'll discuss later the questions. Our next presenter will be Bertrand Fournier from the EUMETSAT from Germany, and he'll be talking about capability of detecting, characterizing, and monitoring sun and dust storms from operational space observation. Yeah, please go ahead.
Yeah, thank you, Oleg. I'm waiting for the slides. So indeed, I wanted to provide to the audience an overview of the capabilities we have in EUMETSAT for the detection, characterization, monitoring of the dust storm, the aerosol in general. I have my co-author in EUMETSAT, but we work also closely in collaboration with scientists like, for example, Oleg, Jérôme Riedi from Lille also, and Météo France. So this is my summary. I will remain what we mean by operational processors. Then we go into the EUMETSAT mission that can support the dust assessment and a couple of examples. So first, I think it's important to remind what we mean by operational processors in EUMETSAT. It's a specific context related to the real-time, near real-time distribution of the data. It's slightly different from a purely scientific development that you could see also in the community. So by operational product, we mean a long list of commitments. And for us, it means we need to disseminate to the users the data in near real time. It means very shortly after the sensing. We need to have robustness of this data, documentation, stability of the performance, monitoring of the performance. So a lot of things that are very important for this operationality. Very important also, we want to tailor the product to the user needs. We are a user-driven agency, so this is why we want to connect also to the users to better define the product. This is also why we have a scientific development in-house, but also in partnership with the labs to work on that and improve the product and the algorithm. This is what we have on our plate in EUMETSAT in terms of satellite. It looks a little bit like the buffet in the restaurant, the 365. We have a lot of things to hit. Maybe you are familiar with the families of satellites. The geostationary satellite at the top, the LEO orbit satellite with the METOP generation in the middle, and the Copernicus mission at the bottom line. So a lot of satellites and a lot of sensors to support the user needs. And here today for the audience, the needs is to address the dust and thunderstorms. So I tried to build a very general map like that one, and to see what are the general needs for the sand and dust observation. I saw at least three main categories, and I think the first one is and I tried to see which of the sensors we saw before could be useful to address this aspect. The first one is, of course, to detect such an event, and for that we need imagery with a high spatial resolution, the best we can. So that's very important. And currently, we have a couple of sensors in orbit to address that, especially Meteosat second generation, even if it is limited to 4 kilometers. But we have also EVHR on METOP. We have also SLSTR and OLSHI on Sentinel-3. And soon we will have METIMAGE VII in METOP second generation. We have another type of needs, which is the monitoring, and there we refer to the high temporal revisit that when we have detected an event, we want to follow what's happening in a shorter term. And for that, we can rely at least on the imagery from the Meteo satellite. This is the most obvious family of sensors to support that. And to address night and day this need, we can rely on the thermal acquisition. We have currently Meteosat Severi in orbit, and we have also MTG now in orbit with FCI that will provide soon some important information. Another family of needs is to characterize this dust and sand storms. It means a lot of things. It means the quantity of particles, the AOD, the types, so the elevation, a lot of things. And for that, we need sensors or radiometers or systems providing a high information content because we have many parameters to retrieve, so we need many measurements. And there we have a long list of sensors or systems in synergy to provide such characterization. And now I will overview some of these examples on this table and show you some illustration. The first operational product we have is the most important word on this slide is synergy that you see at the top. It is operational for now 10 years on METOP. And the idea is to combine three sensors, GOMI2, EVHR, and ISE to provide a super sensors able to derive a good aerosol product. So we had the three platforms in orbit, so to cover 25 years of operation, so it's very nice. You see it's obvious in terms of spectral combination how we can really extend the information content there in terms of spatial sampling and so on. I will not describe the algorithm, but you see the idea. We have a lot of spectral information, so we can really address the different type of particles and estimate the aerosol optical depth. The only limitation of this product is the spatial resolution, because it is based on the GOMI2 pixel, which is 10 by 40 kilometers. It is assimilated today by Copernicus atmospheric monitoring system for the air quality applications. An example of the validation or the performance of the product, you can see we did some comparison with Aeronet. We did also some comparison with the other sensors like MODIS on the right. As you can see how well we detect the biomass burning, but also the dust event. And at the bottom left, you see a climate data record that we have processed recently. 13 years of data are available. As you can see, we capture all the major aerosol events, including biomass burning, desert dust, and sometimes volcanoes, and pollution, of course. So we have now a good maturity of this product. The second product we have operational is from Sentinel-3, and it is derived from the SLSTR sensor. It's a dual view sensor, which provides useful information, as demonstrated by Oleg, in terms of ability to have directional information and to better retrieve the aerosol. So the algorithm is based on the simultaneous retrieval of the surface and the aerosol. And today we have this product operational. And we hope it will be soon also assimilated by CAMS, Copernicus Atmospheric Monitoring System, to support the air quality application. So it's also a very mature product. And to show you the performance globally, again, we have comparison with Aeronet that are pretty nice. And we have comparison with VIRS, for example, at the top right, MODIS at the bottom right. And you see also a nice illustration on the left, how the dust event is captured over Mediterranean. So it's a nice imagery. Now, in the near future, we are preparing the launch of METOP second generation end of next year. And on this platform, we will have a polarimeter. And I think Oleg has very nicely shown how the polarimetry can really support the characterization of the aerosol. It's a real assess. And because of this information content, so many bands, many views, and polarization, we can really move forward in terms of characterization of the aerosol, the model type, fine, coarse, microphysics, distribution, shapes also. So that's something that we can do today. It was demonstrated on Polder, but with this instrument, we will have at least 25 years of operational products based on polarimetry. And you see on the illustration on the right, you see the standard RGB where you recognize Western Europe and Africa, and you see on the right the same image in polarization where you don't recognize at all the target. This is the polarization. This is why the polarization is useful to capture the aerosol and the clouds. The next, just to illustrate that we have the processor under development currently in collaboration with Oleg. And so this is based on the GRASP retrieval. And you can see here a first example of what we have today, the ability to retrieve the AOD, the error of the AOD, the angstrom, the refractive index, sphere fraction, and so on. So we are working on it today, and it should be ready normally for the launch. The next step will be on the same platform, we have other sensors, and let's go also for a synergy. So let's use this polarimeter, 3MI, and let's combine with UVNS, which is Sentinel-5, MET-Image, a nice imager, and also YASI next generation. And if we do that, we can again build a very nice super sensors, which we call MAP. And I think, again, it's obvious that in terms of spectral synergy plus polarization and directionality, it's a very incredible super sensor that we are working on to derive a much better retrieval. You can see on the image, the color image here, how we symbolically we want to mix the spectral information with the directionality and the polarization. With that, we expect to, again, move forward in terms of ability to improve the AOD, but also better characterize the coarse, the fine particles, the speciation, and maybe a good assessment of the aerosol height, and why not at the end an estimation of the PM25. So that's very challenging, but very exciting. The obvious family of satellite that will support and is supporting already today is the RGB. I think Omar has shown an example for Arabia with Metimage, so this is exactly that. We have the Meteosat in orbit currently with Seviri. The revisit is 15 minutes and the resolution 5 km nadir. We can have some very obvious product like a dust RGB composite and a dust RGB using some very specific thermal bands. And you have an example here with an animation over Africa where we see how nicely we can capture a dust plume and propagation. And we have this night and days because this is the thermal bands. And we have also another type of retrieval based on a more classical retrieval. We calculate the AOD, and here we have, for example, an algorithm with, in collaboration with Météo France. The algorithm is called Aerus. And you see on the right the animation showing how we calculate the AOD every 15 minutes and how we can also propagate in time this estimation of the quantity of particles. That was MSG. Currently, we are entering the era of MTG, third generation, and the new sensor is FCI, which a better spatial resolution, 1 kilometer, and a better revisit, 10 minutes, and even 2 minutes in a rapid scan. You have here an example of one of the first FCI animation where we see a nice, it's not dust, it's a smoke coming from Canada and reaching Spain and Portugal. It's a very nice illustration demonstrating how this system will improve the performance in terms of monitoring of the aerosol plumes, including dust. We are also preparing an evolution of the Aerus product, so the AOD associated to that. That's something we are starting currently and we will have soon in terms of operational product. Nice to mention also that we can also investigate the synergy between FCI and the thermal IRS spectrometer. So that's very important because with the thermal spectrometer we can better address the dust. And so that's very important in terms of speciation and again monitoring with time for the dust events. We have also in the plan, medium term, to derive some GeoRing product. Because once we have this product, dust RGB or AOD, what you want, we can apply that to the full ring. We have Himawari, we have GOES and Meteosat, of course. So we can really move forward into operational GeoRing products. That's something we want to develop in collaboration with partners. And we have currently a demonstrational product, for example, in ICAR in France, showing that, so this is what you see here on this animation. And that's something we target to implement in terms of operational, near real-time product to support the users. So that's obvious, the ability of this product to support the needs. It's just to summarize, you recognize maybe Meteosat on the left, and on the right, top right, you see the PMAP METOP product, synergistic product, compared to VIRS on the middle and MODIS at the bottom to show how all these products are consistent. Sometimes we see differences, of course, but how they are consistent and they contribute to so full system in terms of capability to observe from the space. And that's my conclusion, to remind that EUMETSAT operates today and will operate a suite of instruments very relevant for the detection, monitoring, quantification and characterization of aerosol, but more specifically sand and dust storms. We have already in orbit METOP, Sentinel-3, Meteosat second generation, and now we have also Meteosat third generation, still not providing data, but soon. And coming, we have METOP second generation, Sentinel-3 next generation also. So it's a lot of capabilities that can support the users. We have in our roadmap to develop aerosol products that include improvement of the retrieval in terms of AOD, but not only AOD, all the other parameters, especially with polarimetry. We have also in the plan to develop synergy, so it opens the doors to added value parameters like dust AOD, aerosol model, speciation, why not PM25 at the end, aerosol height also. And we have also in the plan to develop GeoRing as soon as possible. We welcome feedback and connection to the users. It's an important aspect for us because we want a better identification of your needs. We want to tailor the definition of the product and tune the algorithm for that as soon and as best as possible. And we may also need you to support the validation, the in-situ validation. We had a nice example just before in terms of validation, how it contributes to the evaluation of the product. And you have a reminder for the table here in terms of sensor. And that's it for my overview.
Thank you very much, Bertrand. And now we have our discussion session. If there are questions from audience, please go ahead. Yeah, so there is a question over there.
Thank you very much. From Kuwait Institute for Scientific Research, this is Dr. Ali Dosari, a urine specialist. So I have multiple questions, if you don't mind. First, for the keynote speaker, and he mentioned, in fact, about the sphericity of the particles. Usually, this is very critical, in fact, regarding this part, because we usually take the PET surface area, because sometimes some of the particles are like a thread-like, like for Ballagharscite mineral. It's a thread-like. It will be very long, but very short mica also. Mica is very short width, but very long. So it's very critical to use that formula for analysis. The PET surface area, I would propose to use it in future planning, because we use it for multiple dust in the world, and we find the huge differences. Each dust has a fingerprint, and I'm sure there's some of the, this is a physical properties. This is, by the way, one of the papers, our presenter who mentioned the physical properties of dust. If there is something else, is for the second presenter, I think Stephen Victor, I think, he mentioned about the LiDAR. Okay, sorry. The LiDAR, I think we have two major challenges in LiDAR. LiDAR, for example, whenever a country or a place have a huge or massive dust storms, it gives a noise, sudden shot. And this is what we face it in Kuwait and Saudi Arabia and some parts of Saudi Arabia and Emirates also. And other thing is the shipping for calibration. Shipping for the major, this is a major challenge for the LiDAR, which is a cut-off of data. If there is something else regarding
so shall we try to answer some of your questions before you ask
if there is something also for Ala, let me summarize it fairly. As Ala mentioned about Rub' al-Khali, very fine particles. The very fine particles in Rub' al-Khali, but I saw some of the posters, especially for the lady, two ladies, Baramawi, and also the lady is Fahada bint Falah bin Hashra. They mentioned, in fact, the distribution of dust. And usually the dust storms or the dust particles filling Rub' al-Khali is very large particles, not small particles. Usually small particles usually in the northeastern part of Saudi Arabia, Qaysuma and some other countries. Thank you very much.
Okay, so if we understood well, the first question was about the silicon particles, which are very long, right? And how we can model them. I don't know, when we look at regular desert dust, these particles probably do not represent significant parts. So I don't think in current, let's say, AeroNet algorithm or satellite data, we address that. But if you looking at different particles compared to, let's say, spheroids to the, like ice crystals, there is completely different models, which is based on geometrical optics, and then it's accounted. If we would have significant presence of this like long silicon particle, we probably first should analyze like full phase matrix and try to see which model, maybe cylinders or something like that could be applicable. But if they really, as you described, and if we see those features, it would be very challenging task. Yeah, so that's no doubt. And yeah, second question was about LiDAR measurements, which apparently I think you saying that they are very noisy during desert dust. And I would agree with that. Generally, LiDAR data, they have, let's say, much lower relative accuracy than if you compare to sky radiometric data. I mean, the errors are tens of % at least. And I can imagine that during dust storms, where there is a lot of variability in the atmosphere, these errors can be even higher. And then, in that sense, probably the LiDAR data already often very qualitative, and at least we could see what kind of desert dust we can observe by looking at depolarization and like possibly LiDAR ratio if there are non-elastic observation. But it's certainly a problem if you have a lot of variability, a lot of dust in the atmosphere which varies, and interpretation of the data never easy. We often see LiDAR signal nicely interpreted only for a fraction of the atmosphere, like 2 kilometers or 3 kilometers, and after signal noise ratio become unacceptable for data interpretation. And hopefully with new system, with more channels with like fluorescence and so on, we can address those questions better. I think if someone can add something, yeah, please go ahead. Okay.
Okay, I can answer the third question about the fine aerosol particles in Al-Rub'a Al-Khali, right? Yes. Actually, the distribution of the size distribution of the dust or of the aerosols over the region, it's already, I agree, it's dominated by coarse mood aerosols, but there is also fine mood aerosols from dust, okay? Maybe the image I showed, it shows like in the autumn season, relatively in the Rub'a Al-Khali has higher fine aerosols. Maybe it is due to maybe retrieval error, because this size fraction aerosol optical depth we have not validated yet. Okay, maybe, but maybe the aerosols, the fine aerosols also there, more than the extreme part, at the 0.3 micrometer cutoff. Yes.
And there is another questions. I see 2 questions. Could you ask, please? This person?
Okay, thank you. I have 2 questions. The first one to Mr. Dr. Stefan from CMEL. According to approach particle classification, I would like to know if CMEL can support and help meteorological organization like ours in Kingdom of Morocco to specify what kind or type of instrument can be chosen in a specific land or field. The second one, the question is to Dr. Bertrand. What difference or what add value between FCI products coming and FCI IRS? Thank you.
Yeah, okay. Yes, of course, we can provide some help depending on the site, on the environmental conditions. Yeah, so we will provide any help for that. That's yeah. That's all.
So for METOP third generation, we have indeed currently in orbit FCI, which is an imager, with a couple of reflective spectral bands and a couple of thermal spectral bands. IRS is an instrument that will be launched, I don't remember when, but soon, in a second platform, Meteosat third generation also, but a second platform, and it's a spectrometer in the thermal part of the spectrum, very similar to IASI. If we are familiar to IASI, this is very similar to IASI. So it means that when you go in the thermal part of the spectrum, you can visualize mostly the coarse part of the aerosol, which is the dust. So it's one way to capture the dust if you go in this domain. And I didn't have time to comment, but I had on my slide a comparison of the PMAP aerosol product with IASI dust, which is only on the reflective part. And we see we have sometimes agreement, most of the time, and we have sometimes differences. So that's where we need to work on the synergy between the two sensors, because we can capture differently, and the idea is to understand it and to better use it for the retrieval.
Well, there are at least two more questions, maybe first on the right side.
Hello.
No questions, who's there, and then...
Yeah, hello. I'm Chandan Sarangi from India. I especially like to thank the organizer and the panel. It was a very interesting session. So I have a specific question regarding the advancement in the field. I see the initial speakers were introduced about advanced techniques into polarimetry and fluorescence into characterizing these particles. And towards the end, we see the satellite era where we are trying to put hyperspectral imagers more. But means if we are looking at sensor development, so should we focus more on bringing in polarimetry into, in terms specifically for aerosol characterization and optical depth? Polarimetry versus hyperspectral. What are your comments?
Well, it's kind of interesting trade-off. I think polarimetry, it will be, to my understanding, more useful to characterize detailed aerosol properties in total column. Hyperspectral, I think it's more for atmospheric composition, especially I would say more like for atmospheric gases characterization. Although it also has some particular sensitivity about aerosol. For example, UV has observation have a good sensitivity to vertical variability of aerosol in passive observation. So I would say it's better not to trade off. It's better to combine, if possible, and try to develop advanced synergy. This is, I think, latest tendency for this kind of processing, this kind of observation. And that's why we see all these instruments at the same time flying in this space.
Maybe I could add, I think the AOD product is a very mature product. Now this is the most obvious product that quantifies the total column in terms of aerosol. But we have many parameters. When we make a retrieval, we have to make assumption of the aerosol. Either you make assumption or you measure this specificities, like the model, like the vertical distribution, like the many parameters that influence the calculation of the AOD. So if you improve this parameter with the polarimetry, with the spectrometer and so on, you normally also improve your AOD in many situations where it's a bit difficult in terms of particular. So that's important, this idea that even when you improve the other parameters, you also improve your AOD. And again, that's why the synergy is very important, because the synergy gives you additional information on the scene in general, and for you it's a better retrieval at the end of the parameter that you want.
Yeah. Thank you very much.
Okay, Rich, please go ahead with your question. Yes, first Rich, he raised his hand.
Here we go. Okay. First question, general question for the panel. We in the remote sensing world, we tend to have certain blinders. One of those is that we're not making observations at night, and I believe we still have dust and dust storms at night. So how do we compensate for that lack of measurements at nighttime in the remote sensing world?
So one strategy, indeed, we can better characterize during the day time of the orbit because of what we said, the reflective part, the polarimetry and so on. But we can also propagate during night with what we've shown in terms of RGB composite based on thermal band. So if we have a good ability to characterize during day, we have also an ability to propagate during the night. It will not be perfect, of course, and especially in the middle of the night, we extrapolate. But that's something that is feasible. It's an extrapolation, of course, but...
I had a question for Dr. Allah, which is, in your comparison, I had not yet seen such a nice detailed comparison of the MIAC retrieval over desert. But I noticed some of your best results come from MISR, which is no longer going to be available. So how are you planning to compensate for the lack of MISR data?
I think there is a new mission, Maya, which is the next generation of MISR, which is, it has, I think, 4 or 5 cameras looking at the same object. So maybe it can be used. But for MIAC, I think it can be improved in the next version over desert, okay, by introducing maybe more absorbing in the aerosol model, so that can increase the AOD retrieval, especially at high aerosol loading. But for MISR, yeah, the next generation is Maya mission, which is, I think, it will be launched this year or next year early.
Yeah, I will compliment. First, I want to say that, for example, Bertrand just was talking about FREMI mission, and there is already PACE mission, which is in NASA mission, which already flying. And those are multi-angular plus polarimetric. And in principle, they have better coverage than MISR. They have multi-angular observation plus polarimetry. So I think that could be very good replacement of MISR if you look at and coverage is much better. And there was question just here on the left.
My question is, a question from a plain user regarding the short-lived local-scale severe dust storms, like haboobs or any other forms which originate from high convective activity, meaning below the very dense clouds. We usually do not have any proof beside the photos from the social media or any public media, and usually those storms avoid, any measurements, and we have only available maybe daily PM 10 ground measurements average daily, and for these measurements also these storms which are short-lived are mainly invisible. So I was wondering, is there any chance, and polar satellites are never on the place when they're supposed to be, so they almost never catch those storms because they're short-lived and very local. Is there any chance that we have any time in the future the product like you showed, we are aware of that geostationary satellite with this nice pink color, very visible dust, to have any assessment in the future that there is a chance that there is dust storm below the clouds. Can this happen anytime in the future? I will explain, okay.
So who will answer?
Can your products in the future provide some probability that below the clouds from geostationary data, from which we can observe all the time one place, that there is a chance of dust storm below the clouds? Because these products are blind for the dust storms below the dense clouds.
So I see two aspects on the question. The first one is below the clouds. The second one is a prediction.
Yeah, it's the same question, the same point, you know.
Yes,
Can
yes.
it be? Is it doable in the future?
Well, below clouds, probably very difficult.
Yes.
maybe
But
some
somehow-
thermal instrument
Yes.
can.
I have
provide
difficulties to imagine that. I think
From AOD,
We-
we cannot, these storms are very near ground, so
Yes.
AOD is poor for them, but they are very severe.
no, my feeling is that a combination of transport model and real observation is probably the best way.
Yeah, we do modeling, but I always have difficulty to prove with the numbers and any observation that there was dust storm. You have pictures from people. Maybe some meteorological observations that there was a rapid drop in temperature, very strong winds, but on dust it's very hard. And these are very significant events. Okay, not visible in any data as a dust storm.
Yeah, well, basically on the clouds it's hardly visible, so only from ground, maybe network of
They
ground-based
miss
instruments.
yeah, they usually are not observed. They happen when there are no observations. So you think in the future you cannot develop anything to retrieve any single, to show us at least probability that below is a dust storm? No?
Well, it's kind of like reanalysis and climatology and development of meteorological observation together with emission. But of course, if it's a surprise storm under the cloud, very difficult to see.
And of course, it depends of the thickness of the cloud. If it is
It's a high
semi-transparent
convective
cloud
activity.
or a transparent cloud, okay, maybe we can detect something.
This is high convective activity, very thick.
So it's
through the
very difficult.
Yeah, very thick and very high convective activity, and it produces the high surface winds. That is what generating the storm. Okay, maybe sometime in the future something you will think.
Oh, okay, our time is almost finished, but if there are like last questions, please go ahead here on the right.
Question is a little far from dust detection. I just want to know if the EUMETSAT products can provide us in some measurement that we can use in cloud seeding. Thank you.
Use in what, sorry?
In the cloud seeding, detection of water vapor for the cloud seeding. I just want to know if there is a measurement that can be used to detect the water vapor in order to study the cloud seeding.
Water vapor product first? This is
In EUMETSAT.
Yes, so we have that already, and we have also a new generation of water vapor product coming from the METIMAGE especially. So we have that from the GEO orbit and the LEO orbit. So yes, we have some water vapor product, and they support already some of the analysis in terms of cloud development, precipitable water, and so on.
Okay, thank you.
Okay, I think it's time to conclude, as organizer indicates. So let's thank all speakers and the participants of the session. And please announce what next.
Thank you, Dr. Oleg. Spasiba. Now we'd like to invite His Excellency Dr. Jam'an Al-Qahtani to honor the speakers. Starting with Dr. Oleg Dubovik. Dr. Stephen Victory. Dr. Omar Hussein Al-Imam. Dr. Ala Mahausha. And last but not least, Dr. Bertrand Fouine. We'd like to draw your attention tomorrow, God willing, inshallah. We will start our session at 8:30 a.m. It will be the first session that will be titled The Health and Air Quality in Dust Affected Region. It will be chaired by Dr. Ali Dosi. So we encourage you to come at 8:30 a.m. in the morning, and there will be refreshments and snacks at the lobby. And we'd like now to invite you to the research area with Dr. Jam'an Al-Ghamdi and all the participants and the official delegations and also the invitees. We'd like to invite them next door to see the wing of the research area. Thank you very much. So please, before we go to lunch, we're going to take a quick tour, then we shall be going to lunch in the restaurant as we had it yesterday. Thank you all very much. I'm looking forward to see you inshallah tomorrow. Wassalamu alaikum wa rahmatullahi wa barakatuh.